Thank you, Khalid-san. Thank you, Sensei, and thank you, everyone. Assalamu alaikum. I'm Khawla. It's my third time to be in Egypt. I'm so happy and I'm so honored to be in charge of introducing and presenting our university, Kyushu University, on behalf of Shimizu Sensei and other academic staff of Kyushu University. So, without making it long, you may wonder how I ended up at Kyushu University and how I'm introducing the university. Well, like every student who's aiming to continue the postgrad studies, I was looking for a great university that would encourage interdisciplinarity, safer girls, encouraging research, and so on. And that's how I ended up at Kyushu University as a PhD student. So, it's good to start with having a brief history. I believe that many of our attendees are familiar with Kyushu University, others are familiar with Japan, and other young students are ambitious to join the Kyushu University and other Japanese universities. So Kyushu University is one of the imperial prestigious Japanese universities, top leaders in research, science, renewable energies, and so on. So if you'd like to join Kyushu University, make sure that you will be, let's say you will have an excellent education with a rich experience. Yes, Kyushu University is placed in Kyushu Island, as the name says, and it has 12 undergraduate schools, 19 graduate schools, 5 research institutes, and more than 50 research centers, plus one hospital that hosts over 1,400 beds. So from these numbers, we can say that Kyushu University is a huge university. But still, Kyushu University is the home for almost 19,000 students, with more than 2,000 academic staff. And you can see the number of the ratio, student-to-faculty ratio, that reflecting the quality of education and the time for students and professors to communicate. Of course, Kyushu University is one of the top universities in Japan and also globally. And if we consider the concerns of the current institutions on sustainability and renewable energy, climate change, Kyushu University is developing its vision 2030 to focus on climate change, design, science and engineering, and so on. So we hope together we can work together on achieving Kyushu University missions, Japanese, Egyptian, and all international members. And okay, it's like I'm bragging about Kyushu University, but we love to also mention Koichi Wakata-sama, or son, one of the famous Japanese astronauts who has graduated from Kyushu University and joined the NASA famous group. So that makes Kyushu University one of the excellent universities in terms of education and so on. For those who lived in Fukuoka, you may know Fukuoka is one of the most living cities, placed in northern of Kyushu Island. It's not that far from Tokyo actually, because when I go to Tokyo and I say I'm coming from Fukuoka, they say, oh my god, it's so far, have you taken a train? It's just well connected to Tokyo, just 2 hours, and it has beautiful connections to the other cities in Kyushu Island, and as the numbers show, it's ranked among the top cities. And believe me, it's really safe, convenient, well equipped, and beautiful. I'd like to keep you with these beautiful pictures for those who are missing Japan and Kyushu. Yes, so all of the Kyushu University campuses are located in Fukuoka. And let's start with the hospital campus, one of the world-leading campuses, and focusing more on, actually this campus is the home for the graduate school of medicine, pharmaceutical science, and dentistry, and focusing on, for example, treating infectious diseases, including the COVID-19, conducting basic and clinical research, and so on. So for those who are interested to continue research in this field, you will be placed in the hospital campus, plus is the home of the hospital, as I mentioned, one of the top national hospitals, well recognized in Japan. Chikushi campus, where I spent my 3 years as a PhD student under the supervision of Osama Sensei, who is here by the way, and also my colleague Ibrahim-san. So Chikushi campus used to be my home, believe me, Saturday, Sunday. So I used to be related to the Interdisciplinary Graduate School of Engineering Sciences. And as in the morning, our speakers mentioned the importance of engaging in interdisciplinarity field and how this is truly possible at Kyushu University. Actually, I'm an electromechanical engineer, and then I switched to bioenvironmental engineering. So you may ask why it's possible? Well, thanks to the programs available and offered by the school. So basically, Kyushu campus is the home for the graduate studies, focusing on engineering, environmental, and how to solve these problems using technology and science in a good way. And of course, Kyushu campus, the home for the Graduate School of Design, and actually is the only school in Japanese university focusing on integrating science and technology. It's one of the, let's say, the mixture of arts, science, and other technologies. So all of these make Kyushu University as a top university, but not only these, this is Ito campus, one of the single largest campuses in Japan and the main home for Kyushu University, and I believe most of the graduate and in the graduate schools are placed in Ito campus. So it's a huge, really, like almost 300 hectares, and it comprises most of the undergraduate schools and the graduate schools. And by this chance, I would like to introduce the 3 English-based programs that Kyushu University is offering for future undergraduate students. And these highlights the fact that Kyushu University is investing in internationalization. So those who would like to study in Japan, worrying a little bit about the language, you don't have to worry, as Japan is welcoming international students and of course Egyptian students. So this is a brief description about the programs. I would like to discuss any criteria you may ask about later, to know about the details, the requirements, how to apply, and so on. But let's move to the graduate schools. As I mentioned, we have 19 graduate schools, and really they provide big number of laboratories, research equipment, supervisors, and so on for future researchers to execute research and to continue their programs. So you just need to do just visiting the website of the university, look for the suitable laboratories, check the research plan, and learn about the topic and prepare yourself for research. Kyushu University is one of the leaders in the renewable energies. We have a bus in the campus running based on hydrogen energy. I think it's the first bus in Japan. And also we have a hydrogen station. We're leading the institutions in terms of wind energy turbines and so on. Kyushu University is the home for the International Research Center, known as the ICNR, and also for other research centers and institutions. These, like according to or following the availability of these research opportunities, we would like to welcome and to work together to promote research, etc. Kyushu University is the home to the world's largest collection of insects museum, actually. And it's not just a museum, actually. It hosts the laboratory working on silkworm and how we use this kind of research data for future applications. And when we say Kyushu University, we say the huge central library. Actually, it's really huge. It hosts more than 4 million items. Like, for example, a 4-year student would have to read more than 2,000, almost 3,000 books a day to finish all the items. Can you believe it? So this makes a good space for students to relax, to read, to discuss. There are like discussion spaces and so on. And of course, when we say Kyushu University and other Japanese universities, we say the focus on extracurricular activities to have a healthy, ambitious, and excited students. So Kyushu University focus on the students' connection, activities. We have good cafeterias providing different types of food. We have gyms and swimming pools. And also we have the Kyushu University Foreign Students Associations. So students here, researchers, faculty members, even professors contribute to organize cultural trips to introduce Japan. When we say studying in Japan, studying Kyushu University is not only about studying in the classroom, doing research in the lab, but it's also learning the country's culture, discipline, and many other stuff. And this is what makes Japan as a unique destination for us to continue our research, to study, and so on. And I noticed this from the morning's presentation that everyone saying, I have the opportunity, I have this unique chance. So why not to encourage each other and continue working together? And I would like to share these kind of activities that Kyushu University and other universities encourage. And besides knowledge, science, and education, we focus on emotional, social, and cultural intelligence. And this is what makes both countries or different countries close together and develop in terms of research and so on. And by the way, mentioning the internationalization and hosting other countries, Kyushu University is the #1 Japanese university hosting students from the MENA region. We have so far 99 students, and we have 36 Egyptian students at Kyushu University. So this shows that Kyushu University is hosting and encouraging and welcoming international Egyptian students, of course, and looking forward to cooperate with more research projects. And interestingly, I'm sure that most of our attendees are familiar with these, but just to remember that the possibility of joining Kyushu University as an exchange student, as a faculty, let's say as a visitor, is possible to do that thanks to the agreements available between Kyushu University and other Egyptian universities. So please check these with your home university and connect with professors and look on how to work on this together. And one thing that makes also Kyushu University, let's say, famous and interesting among other universities is that it's the headquarters of the Study in Japan project, which is a governmental project funded by the Ministry of Education, Culture, Sports and Technology, known as the MEXT. And I believe some of you know the MEXT as the name of the scholarship that most of the students apply for. So Kyushu University and the MEXT are working together all along with other 30 partner institutions to promote study in Japan. And it's interesting to show that most of the current students coming from the MENA region are coming from Egypt. Let's say thanks to the Cairo office, Kyushu University Cairo office, led by Professor Tamer Sensei, who is doing a great job in promoting Kyushu University and also to other international offices. So just for your curiosity, as of May 2023, we have more than 300 Egyptian universities, and we hope to work on selecting top students who are aiming to contribute to the research. Of course, all of the Egyptian students, they are aiming to apply for other universities, and that's what we aim for, to connect with more universities and to keep a strong network, alumni network among the Egyptian applicants and graduates. As a Gemini office, we aim and we work hard on keeping these activities, connecting with the embassy, with the JICA office, and with other governmental institutions to connect, to promote, and to encourage research cooperation so we can develop this win-win situation for both countries and students. Here, I believe we already have Dr. Zakaria here and Ibrahim San. So as a part of promoting the Japan and Kyushu University, we believe in the fact of sharing the experience and how to not convince, but how to share the truth of being a student, a researcher in Japan. It's common to say maybe it's in terms of geography it's quite far, in terms of language it's quite hard, but believe me, we can work on that together, and it's not impossible there are places at the end, so we can go and back. So also, before ending, I would like to introduce to you the Gemini SNS platforms. It would be great if you can join us, if you can share these with future researchers, students, to work together on promoting Kyushu University, one of the leaders, and also other Japanese universities. If you would like to know more about the programs, how to apply the requirements, we invite you to connect with us and with the Kyushu University Cairo office, all along with the embassy's cooperation, to make you understand about the application process, the different programs, how to apply. And something important to note that the Egyptian government offers scholarships. So you can also be applying for the Egyptian governmental scholarships. But also it's not expensive to study in Japan, actually. It costs less than $5,000. So the idea of traveling to Japan, because it's far, it's expensive, I cannot speak Japanese, it's kind of maybe outdated. So Japan is really welcoming Egyptian students to work together on strengthening research. So I would like to stop by here, and I would love to discuss any question you may have later, and thank you very much.
Thank you very much, Professor Kalla, for the insightful overview of Kyushu University and the JMN project. Now our next speaker is Professor Inoue Koji. He's from Department of Advanced Information Technology, Faculty of Information Science and Electrical Engineering in Kyushu University, and he's going to present history and activity of the Center for Japan-Egypt Cooperation in Science and Technology.
Koji Inoue is a professor at the Department of Advanced Information Technology. He also serves as the director of the Quantum Computing Systems Center, the director of the System LSI Research Center, and the director of the Center of Japan-Egypt Cooperation in Science and Technology at Kyushu University. His leading research field is computer architecture, especially for power-aware computing, high-performance computing, dependable processor architecture, cybersecurity systems, 3D microprocessor architecture, superconductor computing, nanophotonic computing, and quantum computing. Thank you. Go ahead.
Thank you very much. So hello everyone, I'm Koji from Kyushu University. So today I'd like to, this is a title as you know my presentation, and I'm Koji, and actually I'm, as she introduced, I'm working as the director of the Center of Japan-Egypt Cooperation in Science and Technology, we call EJAS Center. And also, I'm the director of the System LSI Research Center that is mainly targeting on the semiconductor or large-scale integrated circuit for electronics. And also, I'm the director of the Quantum Computing Systems Center. And this is my main job. I'm a professor of the Department of Advanced Information Technology. And I also just started from this month as a senior vice president of our university. So this means my university is telling me, you have to work more. So I have to do a lot of things. So, but I'd like to change the presentation title very sorry because this is I understood what does it mean, the KYUDAI now. So today I would like to share what's the today of the SLRC, that is the System LSI Research Center, the today of the Quantum Computing Systems Center, and also the today of the EJAS Center. So you can know a lot of things, okay? So the first, I would like to, okay, this is the two parts. First, I will introduce the SLRC and QCSC now. And part two, I will introduce the EJAS Center now. Okay. So in our SLRC or QCSC, we are doing advanced electronics research, technology research. And actually, my group is about 50 members. But this is only my students, but my lab is really international. So as you can see, my students is from almost 11 countries. And we have, of course, one of the students is from Egypt, actually the EJAS. And also one of the students is Sudan. So she also joined to the conference at the EJAS, and then she decided to come to Japan. So now she's a PhD student. And so, before introducing my research detail, I'd like to briefly share the fundamental of computer architecture. So this is a lecture. So I will do some tests after my presentation. So please answer correctly. So how it looks like the computer system? The computer system has two parts, hardware and software. For the hardware, as you say, just like the Intel microprocessor, etc., or AI accelerator. And for the software, you are maybe using the ChatGPT or AI applications. So this combination is a kind of a computer. And this kind of computer is in your bag, or in your pocket, in your hand, just like a cell phone. And also, if you use a car, it's expensive car. We have that about $100 computer system starts working in your car. So in your room, the computer is working at the TV or refrigerator, etc. So the computer is anywhere. And we are always using the computer systems. So the question is how we can design such kind of computer system. So the problem, research challenge is that the computer system exactly improved by year. Like this is a year and this is a computing performance, so higher the better. But unfortunately, we are facing to the limitation of the computer improvement because the computer system hardware is based on the semiconductor technology. And in semiconductor technology, we try to make the electronic devices smaller as much as possible. So right now, the advanced technology, 2 nanometer size of the circuit we can design. And also about the 100 billion of such kind of devices is integrated into several centimeter square. So that is introduced into the PC, laptop, your cellular phone, etc. That is the origin how we can improve the performance of the computer system. But unfortunately, such kind of device miniaturization or device shrinking is limiting to the limitation. So this means that we cannot improve the computer performance anymore. Do you agree this kind of a situation? We are here, oh yeah, right, no, please don't say yes. I will lose my job. Okay? So we have to keep improving the performance of the computer system. So what is the direction? So we have to think about more new devices or new materials, and also we have to bridge such kind of new device and application. That is the role of the computer architecture. Okay? So we have SRC System Research Center and also Quantum Computing System Center. So mainly the SRC is looking at the classical computing system. Okay? For the QCSC, we are looking at quantum computing system. This is very future, next generation computer system. But these have to be tightly connected, co-design each other. So this is our design, our research direction. Okay? So for the classical computing, we use new devices such as semiconductor. These are traditional semiconductor, but we also use the superconductor devices. And also we use a cloud computing system or AI or IoT and mobile and so on. And also sensors. And then try to reach to the applications. I will explain a little later. On the other hand, the QCSC is looking at maybe 20 years later in the future. So that is really, really advanced. And this is almost now in 10 years range. Okay. Then for the SLRC, I will introduce 2 of our projects briefly. So one is the superconducting computing devices. So superconducting devices, we say the SFQ device. That I don't explain the detail, but you can imagine what kind of the research I'm doing. So this is a kind of the integrated circuit, and then we can fabricate such kind of device in Japan, National Laboratory. And that's operates at 4 Kelvin, very, very, very cold world, 4 Kelvin. But in that 4 Kelvin environment, that device becomes to be superconductor state, so almost zero resistance. So that makes it possible to operate really, really, really fast, but really, really, really low power consumption. So usually in Japan, we also have the supercomputers. That is one of the top performance in the world. In the supercomputer microprocessor devices, computer system, it operates at, for example, 2 or 3 gigahertz speed. But this device can work at 100 gigahertz speed. So this means almost 50x faster operation that device can do. So this means your computer will operate 50 times faster operation. So that is our goal we are looking at. And then So actually in the world, maybe I believe that designing the computer system by using such kind of fancy device is can be achieved in our university. Our university, we are collaborating with our university and Nagoya University and some organization or Seoul National University in Korea. But maybe our group can only the team that's design such kind of the fancy VLSI chips. So we designed a microprocessor, and also this is for accelerator for AI application. So let's use superconductor devices to first low energy consumption execution for AI applications. Then we got, this is a kind of the competitive, and the IEEE Micro, this is some the magazine, and then they every year I try to pick up 12 world-best computer architecture researches. And then our students, my students submit that paper, and then that was selected as one of the top 12 worldwide computer architecture research. So that was actually the first top picks paper from Japan, and also still this is the only one. Then the next topic, that is really a fundamental design, how we can design the next generation computer system. But the next topic is we are also looking at how we can use a current computer system for many people, just like the company or a hospital, etc. So here we have the concept of the cyber physical system. So in the cyber physical system, we use many sensors. So let's understand what's going on in the physical world. And then that information is gathered into the very small computers, and then that data is transferred to the cloud system. And in the cloud, we can do a lot of the computations, just like AI or digital twin and so on. And then we do some optimization, and then that result will be transferred back to the real world. So from the physical world to the cyber world, and then from the cyber world to the physical world. This is called the cyber physical system. Okay? So we think about such kind of system should be used for many cases. Okay? But as it's, of course, it's not so easy to design such kind of a system. You have to use the devices, sensor device, you have to use some computers, you have to use cloud computers, how we can connect each other, and so on. So even if our researchers, it's not easy to design such kind of whole system. But in that scenario, the many people cannot use such kind of system. So we try to develop some kind of the platform for IoT system, and then we demonstrated that just only 7 clicks, you can design such kind of a system. Of course, there are many restrictions, but you can do, so you can design by your own system, by yourself. Just like DIY style. Let's design computer system by yourself, okay? Then in that case, the many users can try to design the system and then apply to my application and then do the kind of agile design system. There's so many local companies. It's not giant company. It's very small and medium-sized companies from the agriculture or some state companies and also faculty or etc. So we are collaborating. Our university is collaborating with such with small companies too, and then doing some the next generation the proof of concept by targeting the business. Okay, so the next is for quantum computing system. So actually, we need maybe 2 hours to explain the detail, but it's impossible. So I will skip the details. So briefly, I will explain. Okay. So how many people knows the word of the quantum computing or quantum computer? Nobody know? Okay, you should know. University guys should know. Okay, so quantum computer is trying to use quantum phenomena or features for computing system. So maybe, for example, the IBM or Google or many companies are trying to develop such kind of technology for next generation computer system. But one very critical problem is the quantum computer is not stable. it's very, very, very weak against the noise, especially for thermal noise. So let's say your computer will answer 1 plus 1 equal to always, right? But for quantum computer, they cannot do that. It's a probabilistic style computing. So sometimes 1 plus 1 maybe it's 3, for example. So such kind of the uncertainty operation is the critical issue in quantum computers. So now the state-of-the-art research is how we can solve such kind of problem is doing. Then also against the such kind of thermal noise, still we need to make really, really, really cold environment to operate the quantum computers. So if we look at the superconductive quantum computers, such kind of the device can operate only 20 millikelvin. 20 millikelvin environment, super cold area, right? So in that case, we can reduce the impact of thermal noise. That's why we need such kind of cold area. But the problem is that here, let's say this is the device hardware. So where's the software? Software is the room temperature, okay? And for such kind of device has to be controlled from the room temperature. Room temperature is 300 Kelvin. Device is 20 millikelvin. Okay? The problem is that to control such kind of a 20 millikelvin device, we have to connect between 300 Kelvin and 20 millikelvin. Very, very, very cold world and very, very, very hot world have to be connected. Okay? So in that case, if we have a wire between them, the heat from the 300 Kelvin room temperature will be moved from the room temperature to the 20 millikelvin layer. But if we increase the number of this device, or if we enlarge the size of the device, we need more connection. More connection means more heat will move from the room temperature to 20 millikelvin. So in this case, we cannot keep the 20 millikelvin temperature. That is a critical scalability issue in state-of-the-art quantum computer research. So to solve this issue, we have to move from the room temperature to some cryogenic area for the control circuit or software, etc. But in the world, there is no such kind of a system. So we try to make some simulation or modeling, and then we developed some tool to explore what kind of quantum computer system we can design. That is also our next achievement. If you want to know the detail, please give me 2 numbers and then I'll explain later. Okay? So you will miss the break time. Okay, so due to time limitation, let's move to the next. So second part, the EJust Center now. Okay. So now I'd like to introduce 2 my favorite photos. The first one is this one. This is not clear, but this is the 3 flags you can see. The center is a flag for EJust, and both sides, right and left, are the Egypt and Japan country flags. This is in the EJust. So that was, for me, that was the first experience to see the 2 countries flags here and university flag here in campus. So I was so amazing. I was so impressed from this scene. And then second one, this one. Do you know that? How many people visited EJust? Okay, so thank you. So I'm not sure, that is before the pandemic. And this is in campus in EJust. In EJust campus, they made a Japanese food restaurant. Okay? Then, here, this is a kind of Japanese character, Ejasto. Okay, so we call EJust, but I understand why this kind of character you use. It's a little bit complex and difficult in Japanese pronunciation. But this is, we say, Ejust, not EJust. But this is very interesting, joking or something like that. Okay. So that's my second favorite photos. But anyway, many people knows what is the EJAS project, right? So that is supported by the JICA. And then I skipped many materials, but I got that photo. That is at the beginning of the EJAS. So right, so they decided let's build up the campus here. So that is the origin. Okay. Then the next photo. This is the photo. Just I first visited here. So I think that is basically a dormitory, but there was no building. So we decided to use such kind of a building for classes or etc. Okay, and then in the morning, many people introduced. As I said, the EJAS becomes a really, really top university in Egypt. Then now we have a new campus. So, and our Kyushu University is supporting from the beginning of the EJAS project. Our university joined and also try to collaborate with the Egyptian people. And then now our university is supporting 3 departments. One is electronics and communication engineering, and also electrical power and engineering, and also chemical and petrochemical engineering. So 3 parts we are also collaborating now. And now we, from the 2009, we have our university study the EJAS Center. So the purpose for role of our center is let's accelerate the collaboration with the EJAS, and also let's support the student from the EJAS. And then now we have several professors, and also Abdul Rahman Sensei is there. He also give us some talk. He's now working very, very, very hard for the EJAS project. Right? Okay. So then that is the structure of the our project. Here is the EJAS, and then we have a Kyushu University, and in Kyushu University mainly we have 2 departments. One is the Graduate School of Information Science and Engineering, and also one more thing. And then in this department we have faculties. We have more than 100 faculty members. So our EJAS Center try to bridge between these faculties and also the EJAS. Then if some students ask us, they would like to come to Japan and then do some research, then we try to find the best matching between the student and the professors, and then try to support such kind of research for students. And this figure is, this table shows our history of the EJAS Center. So from the 2009 and to 2024, so in total more than 60, sometimes the same professors is counted on, but more than in total the 60 people visited the EJAS and then had the classes, etc. And also some professors visited our university and then see what kind of classes are going on in the Kyushu University, and then what kind of experiment they are doing, and then bring back into the EJAS. And also for students, in total right now we have more than 50 students. They visited the Kyushu University, and they are the PhD students. So the standard case is they stay Kyushu University 9 months, and then back to the EJAS, and then get a PhD. And also we have double degree program. Unfortunately or fortunately, we have only 1 graduate student, but it's really, really tough. I'm sure, but maybe I think in 4 years, we need to get 2 diplomas. It has to be the different topics, research topics. And then one super excellent student gets that's double degree in EJAS and Kyushu University. And also we have some short visiting. So anyway, many students came to the Kyushu University. There are a lot of photos there. And this is our campus, and he's a double degree student. And this is also the Abra Lama Sensei's or the professor's team, and so on. So they are really enjoying the. I hope they really enjoying their life in Japan. And also, my last message. So, in more than 10 years, we are continuing the collaborative workshop or symposium. So that is called the JCCC, International Japan Africa Conference on Electronics, Communication and Computations. So this is in 2023 and this is 2022. So before, some JCCC was held in Japan and then also others are in Egypt. So and also in December from 16th to 18th, we have the 13th JAP AECC. So please join that workshop. Okay, so this is my last slide. So today, thank you very much for inviting me. So for such kind of really exciting and interesting event. And this is a KYUDAI now. That's a today. But we have to, of course, go to the next step. As in the morning, he's introduced also. So it's a future tomorrow. KYUDAI future, KYUDAI tomorrow. We have to think about it. So please, we need to accelerate the strong collaboration with you guys. And please join us and then please support us. Then make the next generation with us. Thank you very much.
So what's the question?
Question?
Yeah, Q&A.
Oh, no,
You say how we
We have 5 minutes. 5 minutes for question. Yeah.
Okay, sure. Go ahead.
Thank you very much for this interesting presentation. Just my question is very simple. When do you think that we will have a quantum computer in Nanotechnology?
Oh, I see. Thank you very much. So, actually, in Japan, there is a national project, and then first they decided it's 2050. 2050, but based on the more technical improvement, especially from the US side, we are setting the target about 2040 or around this. Yeah, but still, I'm not sure I'm arriving that timing, but yeah. Actually, there are several types of the quantum computers. And then one of the quantum computers is just to solve the optimization problem. In this case, already that became the product. But that's 2050 means, as well as our current laptop or any application, general purpose, that becomes 2050, their thing. Yeah. Any other questions? Sure.
Supercomputers with minimal energy consumption.
Yeah.
Can we use it in the desert, for example, with solar cell?
I see. Thank you very much. That's really interesting question. So yeah, I think that we can do it, and this is really interesting approach. So, but in that case, we have to make really strong internet or network communication. So because the tons of the data will be sent from the all worldwide and then to that supercomputer center. So network has to be one of the critical challenge to do this. And second one is in supercomputer, that's sometimes we execute, let's say, very heavy applications. So in that case, 1 day, 2 days, 3 days, application have to keep working. But let's say in the supercomputer system, actually, maybe I guess more than several millions electrical parts have to keep correctly working. So if we have some fail, some guys have to do the maintenance. So such kind of maintenance environment we have to develop. So if we can make such kind of environment, that should work very well. But anyway, not only supercomputer, but also data centers or any computing system, the energy is one of the critical problems. So I think there are very huge opportunity to use solar power and then, yeah. Thank you for a great question. Yeah.
Many questions.
Okay.
Thank you for your presentations. Let me just highlights, because as you know, last couple of days, there is an announcement for the Nobel laureates, which is going to be for the both subject of physics and chemistry. Both are related to the AI, artificial intelligence. So what do you think? Because in the near futures, we're gonna switch our research from the basic and wet labs to be using the computers, you know. So what do you think about that?
I see. So it's really a tough question. Yeah, actually, there are two directions: the AI by some sciences, and also science for AI. So the both directions we have to think about. And even if the supercomputer area, we are also trying to use the AI technology to accelerate the traditional classical application software execution. So let's use some prediction by using the AI. Then predictive result will integrate into the current applications. So such kind of collaboration or cooperation becomes really the key, I guess.
Maybe the last question.
Thank you very much. Very interesting.
Thank you.
When you need to improve the technical characters of the computer, how to choose the materials that could you help for that purpose?
So you mean
The materials.
materials?
Yeah.
I see. That's also a tough question. But basically, there are several things. So in the computer, there are many metrics. For example, the performance, power, energy consumption, reliability, etc. So many research do the very good performance or low energy consumption with some materials. But sometimes the problem is reliability of that material is not so good or not immature. So if we use that becomes the product, the reliability becomes to be really important metrics. So the many aspects we have to see: power, performance, reliability, etc. for the materials. But I think the next direction of our research is so far the material people, computer science people are the different area, and then application people are different area. But we have to do the co-design, so cooperative development we have to do. So maybe the material people and also computer science people have to handshake and then do something.
I guess that's it for the questions. Thank you so much.
Thank you very much.
Now our next presenter is Associate Professor Abdurrahman Zakaria Ahmed. He's from Faculty for Engineering Sciences at Kyushu University. And the title is Green Synthesis of Nanodiamond Films Using Physical Vapor Deposition, a Versatile Approach for Modern Applications.
Professor Abdurrahman is an associate professor at the Faculty of Engineering Sciences in Kyushu University. He is a member of the Internationalization and Future Conception, also known as IFC, department at the Center of the Japan-Egypt Cooperation in Science and Technology. He's a JSPS alumnus and a Kyushu University alumnus as well. His research group is developing nanodiamond films for various applications, including electronic devices, anti-corrosion coatings, and implants. He has more than 50 journal papers and 15 talks at international conferences. In addition, he has contributed to promoting study opportunities in Japan at several online and on-site events. Go ahead.
Assalamu alaikum wa rahmatullah. Konnichiwa, or good afternoon, everyone. As introduced by Sama, my name is Abdurrahman Zakaria, and so I'm currently Associate Professor of Faculty of Engineering Sciences in Kyushu University. And actually, I have been in Kyushu for about 11 years, maybe now, and I'm very happy to be part of this nice event. And as it's mentioned that morning, that will remain as a historic event because it's the first event to be held out of Asia for Kyushu University. So even they hold a lot of events, then that will remain as the first one to be held in Cairo. and I will be also honored to mark my name belong to the members. Our research in Kyushu University is about synthesis of nanodiamond material by kind of green synthesis methods, physical vapor deposition. So for today, I will give a brief introduction about the lab activities and what kind of research we are doing, and extra, but also in a brief points. And actually, I was unlucky to be just next to the nice presentation of Professor. You know, he already did a lot of let's see all of the presentation skills that you can know. He was very energetic, and he can move in the stage, and all the presentation skills that we learned, he applied. So yeah, and I'm really honored to be working with Inoue Sensei for almost 4 years for IJAS Center, and we continue to work together for a long time, I hope so. So this is an outline of my talk today. At first, I will introduce myself about my career and education background and lab overview. Then I will turn to the main topic of my research in Kyushu University, and I will introduce the nanodiamond, what is nanodiamond, and how we fabricate, and finally I will give or shed a light on some applications. So at first, here is a self-introduction about myself. I'm currently, as mentioned, associate professor since this year at the Faculty of Engineering Sciences. And before that, I worked for IJAS Center together with Inoue Sensei for 4 years as assistant professor and then associate professor. And before that, I was a GS-based postdoctoral fellow for 2 years at Kyushu University. And during my postdoctoral fellow, I worked a little for like 4 or 5 months at North Carolina State University. And before I moved to Japan in 2013, I was working at Aswan University in physics department. About my academic career, I got my PhD also from Kyushu University. So I'm like participating as two alumni. I am alumni of Kyushu University, and also I'm alumni of GSPS, and I'm Egyptian working in Japan. So I have a lot of contributions to this event. So, and I worked as I get a research student 6 months at Kyushu University, and I got my master as an exchange student with Graz University in Austria and also Aswan University. So, and my bachelor also from Aswan University in 2006. So this is kind of internationalization, because this event is mainly for internationalization beside our research. Actually, I have doing such international activities either in kind of work and also as a volunteer. So just this, you can see the upper left side. This is maybe it's quite small from far, but this is the rank of students, international students at Kyushu University. So if you can look at the top 10 countries, you will find most of them, maybe 8 of them are Asian, and number 7 is Egypt, and number 8 is US. So we are more than the US international students at Kyushu University, and we are only the African or Middle East country that we have the most or biggest number of students. And it's should be 39, but I just mentioned 36, maybe 3 students already graduated last semester. So during my stay in Kyushu University, I contributed to a lot of activities, international activities. For example, I joined the alumni certification ceremony in 2022 online with many members. And also I worked or just volunteered as head of the ESAG, Egypt Student Association in Japan. And we welcome all Egyptian students come to Kyushu, and we held 2 times a welcome party in April and October. All this organized as a volunteer work. Also, I gave some online talks and on-site talks in IJAS, also in Aswan University. And online talk, I contributed with BOE, invited by my friend Dr. Hassan Najah, and it was organized by UNESCO. And also in last February, I was happy to organize a Sakura Science program. At that time, I could manage the visit for 10 students or 10 members from different countries, and especially from Egypt. We got 4 members from Egypt. They joined for, I believe, 1 week. They got a very nice experience to see Kyushu University. So this is about the international activities. So next, about the lab overview. Actually, as I mentioned, our lab is located in Kyushu University in Chikushi campus. And Chikushi campus is, you can see over there the map. It's in Onojo City. In Onojo City, which is 10 minutes from the downtown, from Hakata. And these pictures are the picture of Chikushi campus in different 4 seasons. So here is our lab in Kyushu University in Chikushi campus. Actually, when I joined this lab, the name was Yoshitake Lab only, and Professor Yoshitake was my supervisor. Then year by year, I contributed to the lab, and now the lab name became Yoshitake Abdurrahman Lab. So, and if you look at the members of this lab, this group, you can find from the professor, associate professor, assistant professor. But the important thing that if you look at the doctoral course students, you will find we have 4 doctoral course students. All of them are Egyptians. Okay, we have 2 students gonna be graduate next year, and 2 students just joined us this October. And also we have, if you go down to the master students, we receive 1 student. Actually, he came from Qatar University, but he's originally also Egyptian. He joined my group as a master student. We also receive many students or visiting researchers from Egypt. You can see in the table we have visiting professors, Dr. Hussein, and also we have internship students from EJUST. Now we have Mustafa, and next is another student is coming to my lab in November. So let's move to the second part about the research in our lab. Actually, in our lab, we're fabricating mainly material. We just believe it's a kind of unique material because of 2 novel things. First is the properties of material, and second is the method that we are fabricating this material. And the name is nanodiamond material, nanodiamond films. So nanodiamond films is a kind of course, diamond, and diamond is made of carbon. So the most important thing about the carbon atoms that it's naturally existed, and it is give a very huge variation of forms because of just changing the allotropes or the arranging of the atoms. So it can be a soft material as graphite, or can be very, very hard material as diamond. So this is the importance of carbon. So all carbon-based materials are still very hot topic for many researchers all over the world. So for that, the carbon itself is the name of the journal in US, and also there is a journal name is Tanso, which is carbon in Japanese. So here's a just brief comparison between different kind of nanocrystalline diamond materials. You can see from diamond like carbon or amorphous carbon material, and nanocrystalline diamond, and also the third is polycrystalline diamond and single crystalline diamond. If someone is working in material science and even chemistry, physics, or any related science, he can understand what's different between the nano crystalline sizes and polycrystalline and single crystalline. It's just a kind of, we named, depend on the long range order or short range order. If it's crystal, that means the long range order of the atoms is completely well ordered, so that means the material is single crystal. And if it's quite not that long, it becomes polycrystal. And if it's very short, that means it's nanocrystal. And of course, the material properties are changed based on the size of the atoms and also the arrangement of the atoms together. So in our case or our group, we are focusing more on nanocrystalline diamond, and it gives very good properties compared to the diamond-like carbon or amorphous carbon, and it's also not expensive as a single crystalline diamond. So in the market applications, nanocrystalline diamond already established by some companies. They already start to do the commercial products of nano diamond. They are using in different applications for example, wafer scale diamond, and also they are using the diamond MEMS biosensing. They are using it in biosensing, even gas sensing or other sensors. They are using, because of the hardness, very strong hardness value of the diamond, it has been used for a long time as a coating material, even for hard coating or sometimes for lubricants. Other companies are working in diamonds or for water treatment. Diamond can be used for water treatment, and also the one researcher from Germany, he discovered the coated microchip implantable in the retina to restore the sight of some blind people. So this one also achieved, and I believe it was published in Nature. So this is the current applications or recent application market about the materials that we are interested in. So now I'll move to the method we are doing at our lab. So all previous applications we mentioned for nanodiamond mainly used by different techniques. So for our lab, we are focusing on a unique technique. It's kind of physical vapor deposition approach. This technique, we call it coaxial arc plasma deposition method, or it can be abbreviated to CAPD. So here's the formation techniques of nanodiamond. It, of course, when the people discovered, it was, I believe, a Russian group, they discovered the fabrication method of diamond and nanodiamond. They just apply the same conditions of the natural diamond that formed at the deep earth. So they apply very large value of heat or temperature and large value of pressure. So the most famous method is called HPHT, high pressure, high temperature method. That is just they copy the method of the natural diamond. But this method is not succeeded so well because if it's quite hard to control at the lab and so on. Then they also use the different methods, for example, dynamic senses of nanodiamond, and they use the most conventional method, named is CVD or chemical vapor deposition method, which is a research topic of many researchers or scientists all over the world. In our case, we are using physical vapor deposition. Most members of our group are coming from electrical engineering and applied physics. So we're more interested in the method itself to develop new methods out of the conventional method that completely use the chemical or the wet lab. So in the physical vapor deposition, we are developing two methods: physical pulsed laser deposition or PLD, in which we use laser energy to irradiate to the graphite targets, and then we start to receive the high energetic carbons, and it starts the growth of nanodiamond. Another method, we use the coaxial arc plasma deposition or CAPD. Then I will compare between the methods in this slide. So this is first, as I mentioned, it's a conventional method in many labs in Japan and also different countries. The CVD method. In the CVD method, the excitation source of carbon is the microwave, and the source material is the gas, it's CH4. So by using this CH4, we need to grow nanodiamond made of carbon. But before we start the growth of this material, we must do some seeding for the substrate. So if we want to grow nanodiamond, there's this black substrate. So whatever the substrate we are using to grow the diamond, even it's metal substrate, glass, whatever, or silicon sometimes, we need to do some seeding or pre-treatment of the substrate to attract the carbon, and the carbon start the nucleation and start to grow the nanodiamond. So for this method, they need the pre-treatment of the substrate, and also they need high temperature, reach 2000 Celsius. On the other hand, in the physical vapor deposition, one method is called pulsed laser deposition. As I mentioned before, we just irradiate the source material, which is graphite, and graphite of course made of carbon, and it's very cheap material, so we can buy from a company in Japan like 10 centimeter rod of graphite with almost 2,000 yen. So we can use this cheap material, and we irradiate with argon fluoride excimer laser, and by this irradiation we eject very high energetic carbons that flow from the target to the substrate. For this method, we are not forced to treatment or pre-treat the substrate before growth, which is a very important achievement, that we skip one point from the different methods. And also we can grow in 550 Celsius, which overcome the problem of CVD method. So the method of coaxial arc plasma deposition, which is CAPD. In this method, the excitation source is the arc discharge. Instead of laser energy, we replace by arc discharge. And by using the same source material as graphite, we are not required to treat the substrate before the deposition or the growth. And also the growth rate or the deposition process is faster than the pulsed laser deposition, and also faster than CVD method. And the most important achievement on this method that now we are developing more, that we succeed to grow nanodiamond at room temperature. So this room temperature growth of nanodiamond opened the door for many applications that was limited by the high temperature of CVD and also the 550 Celsius by PLD. So, for example, we can grow now on some plastic substrate, because it was not possible to grow any nanodiamond on plastic substrate, because at least you need 550 by PLD and 1000 Celsius by CVD. But by CAPD we can grow at room temperature, so we already overcome the limitation of the type of substrates, so that it's opened the door for many new applications. So here's the real image of one chamber that we own in our group. Actually, we have this chamber, is a sphere chamber. In this chamber, I got my PhD. So we have now maybe 5 or 6 chambers with different design. And this chambers designed on lab, we design, then we send to the company, and the company, Alva company, maybe it's famous company in Japan and also all over the world, they just manufacture the design we send to them. So we have the sphere chamber, we have cylinder chamber, we have multi-gun chamber. Multi-gun means we can operate different sources at the same time. So this the importance of multi-gun chamber that we can use. As I mentioned, the source is graphite. So if we use graphite doped with, for example, boron, and also we use the graphite doped with different material and only graphite, that means we can incorporate different atoms at the same time by using the multi-gun chamber. So for this, during my PhD, I worked on this chamber, and I was more interested about the nitrogen-doped nanodiamond. So I got my PhD in nano-doped nanodiamond. It was the first time to achieve the N-type semiconductor by using nitrogen-doped or nitrogen doping on CAPD. So at that time, we flow hydrogen and nitrogen inside the chamber, and we operate the process. And finally, we can grow nitrogen-doped nanodiamond, which will be explained in the next slides. So now we come to the application of nanodiamond that we are doing in our research group. As mentioned, I started my research in nanodiamond in 2013, and for the nitrogen-doped nanodiamond. So as I mentioned previously, we just flow nitrogen and hydrogen inside the chamber, and by that we can cooperate or incorporate the atoms inside the matrix, and we investigate the contribution of nitrogen into nanodiamond by XPS and many other structural investigation to confirm the existence of nitrogen from the flow gas inside the material itself, bulk material and also the surface of the material. So we discovered the TIM and observed many other measurements for structure. Then I studied the optical properties of the material before doping and after doping with nitrogen. Then we found that nitrogen contribution to the nanodiamond shrink the band gap or the optical band gap. That means create some states inside. So we also improve the electrical properties of the material. Of course, by nitrogen we can enhance the electrical conductivity, but also improve its kind of N-type semiconductor. So once I confirm it's the N-type semiconductor, of course I apply to the diode p-n junction. For p-n junction we use the p-type silicon, commercial silicon, and I use the N-type nanodiamonds that we fabricated, and we could fabricate a diode with a very nice rectifying action. And also we did a lot of things in this electronic application or electronic device applications. We measured the CD, then I applied it as a photodetectors for the UV light. So for the same application of the electronic devices, recently we discovered that the material nanodiamond we are fabricating is very strong material against the acid. So we got one of our PhD, his Indian PhD, he worked directly with me about this project. In this project we grow the nanodiamond on the surface of single crystalline diamond. In the single crystalline diamond, there is a challenge of the contact or the ohmic contact. They have the titanium ohmic contact, which is a metal ohmic contact. So when they try to operate the device with the conventional or commercial titanium ohmic contact, the peeling off happens. So they should limit the condition or the harsh environment for the devices used here. So for our case, we grow the nanodiamond by CABD on the surface of diamond substrate or diamond material, and we use some mask, as you can see there. By using this mask, we form the ohmic contacts, and just by touching the place of the deposition, we get the electrical conductivity. And this one tested under very high or harsh environment under the boiling acid. So the device inserted in the boiling acid, okay, 3 minutes, okay. So this tested under the very harsh environment, and we succeed to find the stability of this electrode. And this is very interesting topic, and we are just started maybe 2 years ago. So another application is the implant. We are using this, so now Jimmy Sensei is listening so much because he's coming from the same department. So for implants, this is of course the brief introduction about the implant. Just simply, the implant is, we just put some material in the root of our teeth to keep it for a long time. So actually we found the main material used, titanium or zirconium, are being eaten after time. So we need to do the operation again, take off the teeth and then implant again. So the researchers are discovered the coating of the implant with hard material, non-toxic hard material. So we started to do some research on this area by using the titanium substrate and coat with nanodiamond, and then test the implant or the biomedical properties. So at first this research started from zero, just maybe 3 years ago. So we tried a lot of times to deposit nanodiamond in titanium. So if someone working in material science, so there is a very big challenge to deposit film on a different material because of the physical properties of the two materials. You want to combine them together. So we found, of course, there are a big difference between nanodiamond and titanium. So we try to overcome these challenges, interface properties, and many other So we tried many structure. We insert the titanium carbide layer to work as an interlock between carbon or diamond and the titanium itself. So, and we did a lot of effort. It was a PhD work of one of my students. And finally, we did some research on the different kind of treatments. So, and we found that it's better to redesign the machine itself. So that we design in this picture. This is the main machine we have. We redesigned by open a window and we include the argon etching in situ to etch the surface of titanium under high vacuum. After that, we rotate the holder to face the arc gun and start the deposition. So that because every time we just start to deposit and after take out the sample, the diamond is gone because of the oxidation layer and many other things. So after maybe 2 years of working, we found this is the main problem is the titanium dioxide formed, so that we redesigned the machine to this shape, and we succeeded to grow the nanodiamond and titanium with very nice thickness, 3 micrometer, which is very big thickness even compared to DLC researchers. So after that, we characterized by with Mrs. Lama. She came from also Aswan University, and she did PhD with us, and she could characterize the structure properties of the material. After that, she applied the bias. The bias means we apply negative bias to the substrate, so that, as I mentioned, the carbon are coming from the target with the C+ or C++, very high energetic carbon ions. So when you apply the negative bias to substrate, that means you attract such very high energetic carbons, so that you increase the thickness and you improve the adhesion of the material of the nanodiamond on the substrate. So she did a lot of tests, and she could reach to very super hard material, reach to 96 gigapascal. So for another application, this is quite a new topic for us, quantum centers. So quantum centers, maybe it's sometimes related to quantum computing, but for centers, we just focus on NV center, which is kind of defect in the diamond research area. So in our material, of course, we succeed to grow a nitrogen-doped diamond. So we try to grow the nitrogen-doped diamond, and then we irradiate by some high energy so that we can create vacancies. And if we can create vacancies, we can use it for a biomarker or many other applications. 1 minute, right? Okay, so this is another also topic I just started last year. Just 1 minute, right? So I just started last year. I get a collaboration with a nice professor from Taiwan, Professor Lin, and we get a small fund actually from Kyushu University. I hope next time biggest fund come. So we could fabricate the nanodiamond on the surface of magnesium alloy. They are very strong research group in magnesium alloy. So we coat it with nanodiamond and we use it for biodegradable implant. Instead of the metal implants, titanium, we use a biodegradable implant. So we have partially succeed on this topic, and also we have collaboration after the fabrication of magnesium alloy. We coat at Kyushu University, and then we sent to Dental Implant Center, Ayagawa Sensei, and he is doing the cultivation test experiment and so on. And also for the same research, we recently started a new project. The name is develop the high performance magnesium alloy with anti-corrosive surface coating of nanodiamond that will be used in unmanned underwater vehicles. This vehicles is used as sometimes for military, but this is the problem of the salt water when we use the material of the vehicles, underwater vehicles. They have the problem of the corrosion. So we start to use our material for this application, and we hope to succeed. We just recently, from December, we will start this project under new grant. So this is the last application. We try to shift a little to the chemistry because researchers in chemistry are more active than our topic. So we try to attract some chemistry researchers. we did some, or we still doing some research in CO2 reduction, just started last year. I got a grant from Marubeni company in Qatar branch. They have big company and they support the Japan-Qatar collaboration. So I applied and I got the grant for 1 year. So we developed the nanodiamond with copper. So, and the reference paper was this paper. At that time, the guy, in, I believe he's from Stanford, so he deposited the nanodiamond. After that, he attached the copper atoms on the surface of nanodiamond by RF sputtering. So in our case, we are developing the material which contain the copper from the beginning. By developing the target, we use a graphite target doped by copper and we deposit at once, so that we can get the nanodiamond doped by copper from the first time. So we are developing this project now. That's it. Thank you very much.
Thank you so much, Dr. Abdurrahman. I am afraid there is no time for questions now. You can ask him in the free time if you do have questions. Our next presenter is Associate Professor Osama Jamal. Osama Jamal, Head of Water and Environmental Engineering Laboratory, Interdisciplinary Graduate School of Engineering Sciences at Kyushu University, is going to introduce nanotechnology for environmental remediation, water treatment, and energy recovery.
Osama Jamal obtained his undergraduate degree in civil engineering from IUT Palestine in 1997. He also received his master and PhD degrees in environmental engineering from the Graduate School of Engineering at Kyushu University in 2006 and 2009 respectively. He joined the Department of Earth Resources Engineering at Kyushu University as a GSPS postdoctoral fellow from April 2009 to October 2010. After that, he was appointed to the Graduate School of Bioresource and Bioenvironmental at Kyushu University in 2010 as an assistant professor. Afterward, he was promoted to associate professor in Interdisciplinary Graduate School of Engineering Sciences, as known as IGSES, at Kyushu University in 2014. His research interests covers over environmental remediation, water purification, wastewater treatment, bioenergy production, and environmental molding. He has served as a supervisor for over 30 PhD graduate students. He has also served as session chair, conference organizer, and a member of Research and Education Program Committee for many scientific conferences and international research and education programs. Currently, he is the head of the Water and Environmental Engineering Laboratory, as well as the chairman of the annual International Exchange and Innovation Conference on Engineering and Sciences, as known as also CES. Also, he serves as a board member for the International Advisory Group for Kyushu University President. Sorry for taking too long.
Thank you for this look. السلام عليكم. أهلا وسهلا فيكم في التنمية. So, good afternoon everyone. I really want to make my presentation short as possible and simple also. So, the title is about nanotechnology for environmental remediation, and I will mention some samples about the application for water treatment and energy recovery from the wastewater. But shortly, I'm from Palestine and I moved to Japan 2003 to obtain the master PhD. Then I become the GSP's postdoctoral and assistant professor from 2003 until now in Kyushu University with the environmental engineering subject. So many people thought I'm from Egypt, but actually I'm from Palestine, but I would be proud to be Egyptian because we share the same culture, language, religion, food, and the future hope also. We have the same thing. So just confirming the information from Khawla-san, Fukuoka city, this is really amazing city, and it's #1 in many things. related to their life. So really attractive and interesting city, which is located in the Kyushu Island, and it's very close to the South Korea and to the China, and really me at least love Fukuoka too much. So this is pictures from Fukuoka showing how Fukuoka has some strong and good, nice downtown urban area, and also some natural, like these cases, and also some historical place. So if you have a chance, please visit and see beautiful Fukuoka. Khawla-san mentioned also in the presentation, in Kyushu University we have about 18 or 19 graduate school. We have the Graduate School of Engineering and we have the Graduate School of Science in Kyushu University. But we have also unique special graduate school, different from all, right? Because we combine engineering with science and we make the Graduate School of Engineering Science. This is very special. We use the fundamental of science and the application of engineering in this school. This school occupied one campus. We are separately from the main campus. We have our own campus, quite small campus, but so beautifully quiet campus, and it's very close to the center, Hakata city, just 10 minutes from Hakata and 5 minutes from the airport to Hakata, then you arrive to the campus. Very, very useful place. In the campus we have, as I mentioned, the Interdisciplinary Graduate School of Engineering Science, we call IGSES, and we also have 3 attached institutes focusing on the research. So this is the image of the campus. Also, I just want to mention here, I bring some material about the Chikushi campus and this school. So please, you can have more information if you ask Khawla-san to give you. And there is a QR code here. You can scan and get more information from the website. So inside the campus, already Abdurrahman maybe shows some picture, but you can see these 3, white in spring, then green in summer, and yellow or red in autumn. And in winter we have a little snow, beautiful, and you can imagine all these things happen in the fall season in one campus. So we got also KISA. KISA is Kyushu University International Student Association. Actually, I am the founder of the KISA. Also, Khawla-san was a member of the KISA 2014 or 15, and KISA doing too many activities inside the campus and outside the campus. We have more 40, students from more than 40 countries join the KISA activities, and sometimes we have barbecue inside the campus or trip outside the campus. So back to the research. So in EXIS, we have 3 research areas covering material, engineering, and environment. And as I mentioned, we accept students from the science and engineering because you can find almost all the research topic here related to engineering and science, because we have 65 labs with different topics inside the EXIS. One of those labs is Water and Environmental Engineering Laboratory. We call WHEEL. This is actually my lab, and in this lab we have 2 main research themes. One about the environmental remediation, focusing in water treatment, and the second one about renewable energy, focusing about the bioenergy. We use the fundamental of science and the concept of engineering to improve the system, and we also apply and get the advantage from the nanotechnology to improve the efficiency of the water treatment and energy recovery from the waste. So why we focus about water? Because we believe the water is the most important thing for our life, and we need water year by year because our lifestyle, population increase, and we have problem still in the wastewater. Most of the wastewater released to our environment without treatment or without sufficient treatment, so we suffering from that. In 2023, United Nations World Health Organization mentioned 2 billion people still don't use safely drinking water until now. This is a big issue. So we believe the treatment of water or wastewater is an urgent thing, and we have to work using the science and technology to improve and increase the system. So energy, as you know, very important sector, and almost we have some issue with the energy, and so far most of the energy comes from the fossil fuel, and which is the source of the carbon dioxide emission to the atmosphere and so on. But also in my lab we believe renewable energy is very attractive and it's the future of the energy. So we focus in the bioenergy to generate bioenergy using some technique from the nanotechnology. I will bring sample from our research today. The first sample, before that I would like to mention, to have the nanomaterial, we have two approaches, either from top down physical mechanical technique or from bottom up, which is chemical reduction technique. Then we can obtain the nanomaterials. So in my lab we follow this approach because we can get a fresh and reactive material, and we can control the things by this way. We use this characterization device which already exists in Chikushi campus. For example, we use the XRD to obtain information from the nanomaterial about the crystal structure, composition, FDR to get the surface area bound or the surface bound with the material. We use the laser particle size to determine the particle size of the materials. Also, we have the TIM and SIM to electron microscopy. We can get information about the morphology, structure, shape, size, and more than information, as well as we apply the PET surface area to get the surface area of our material. Actually, we use this device to characterize our thesis nanomaterial. Then we apply this nanomaterial for either treatment or energy. Then we again characterize them by see the difference in characterization. We can understand the mechanism, the behavior, what kind of interaction happen inside the system. This example is about the chromium removal, one of the heavy metal, and it's a big issue now about, the existence of the heavy metal in the groundwater. So in this project, we fabricate a groundwater scale system inside the lab, something like this drawing, and this is the picture. And we introduce the nanomaterial into the aquifer by injection well, and we operate this system to see if we can remove the chromium from the groundwater. Then the result showing that the chromium can be removed totally from the groundwater by, of course, different mechanism, reduction mechanism. Hexavalent chromium can be reduced to tetravalent chromium, co-precipitation between chromium and the other metals, and also adsorption, physical adsorption to the surface. So this information, actually too much information, if you are interested, you can find in this paper, which published in Chemical Engineering Journal, one of the top in our field, actually. And I have to mention very important information here, that the first author of this paper, Ibrahim Mamoun, he is sitting there and he is my student, but now he is my colleague in Kyushu University. Another example, we also tried to simulate something called permanent barrier, which used for the groundwater treatment, kind of wall, contains some reactive material. From this material, the contaminant can be react and we can get the clean water. So to simulate this one, we designed the lab system like this, and we introduced the nanomaterial with different scenario like injection, 1 layer, 2 layer, mixing, and so on. Actually, about 12 scenarios we tried, and from that, we come by the conclusion the best is the injection. We can remove maximum, in this case was the phosphorus removal, one of the nutrients, so we achieve the maximum removal capacity with the injection technique. In this paper also we clarified the mechanisms. We use iron and cover iron by metal nanoparticles to remove the phosphorus, and also we was able to publish this paper in the molecular liquid in 2020. We work in this project with Professor Ian from the Department of Engineering Science. He is the head of the Environmental Bioengineering Program in the University of Oxford, United Kingdom. So we work with him together. Actually, we work alone here, and we were able to publish this paper in this journal with high impact factor. Then when I moved to the Oxford, I thought, oh, we can use the name of Oxford and publish with higher impact factor. But we sent that paper to higher and then rejected. No one respected the name of Oxford in my paper. So I go down for this one. So in Kyushu University alone, we able to publish in high impact. And with Oxford, we go down. Another example I want to mention about the energy, because energy is important. So maybe you can just imagine this system exists in any city. We have water resources, different water resources like river water, seawater after desalination, or maybe lake water, groundwater, or maybe wastewater after treatment for reuse. So that after that we have to purify and clean the water. Then we have like water distribution system in the site, the city distributing the water. We will use the water here and industry use the water there. Then we have wastewater from this side and another wastewater from this side. We call this one domestic wastewater and this one industrial wastewater. This is rich by organic matter, human being discharge. And this is by the different chemicals depending on the industry, sometimes heavy metal or other things. So we need to treat this one before discharging to the environment to protect our environment. So our concept in my lab, we think if we collect the wastewater and do the full recovery following this system, we will recover 100% everything. Water can be treated and used for irrigation for agriculture application. Also, we can recover the nutrients like phosphorus, ammonia, nitrate, and use as a fertilizer. Then we can return this one as food for the human being. On the other side, we can also recover the organic matter as energy. Then we can return that as electricity. Why we have to think like that? Because I want just to ask one question. This is wastewater, right? So this means two words, right? Waste and water. So how much waste and how much water in this? Do you know? Anyone have idea?
We don't know.
30%. 30% waste.
Brian, son?
Water is the majority.
Yeah. Actually, 99% is water, and 1% only waste. So for that 1%, we have to go this system to recover the water and energy and nutrients. So one of the applications we use here is microbial fuel cell. It's very simple device. It has two, chamber. One we call anode, another one cathode, and we supply the wastewater in the anode side. Then some biodegradation will be start, and bacteria produce CO2, proton, H+, and electron. Electron will flow through the circuit to the cathode side, and we get the electricity from this side. And the proton will pass from special membrane and meet with the electron here with existence of oxygen and forming H2O water. So this device basically produces electricity and water. Then very, very environmentally friendly technique to treat and get energy and water from the system. But this device efficiency very, very, very low still, and we need to improve the efficiency. We worked for that, and we were able to improve the efficiency from here to here by using nanotechnology, and it was about 400% improvement in the electricity production using this device and using this different nanomaterials. Actually, we tried different nanomaterials, and then we published this information also into 2021 with the good journal Energy Conversion and Management. And also I would like to mention another important information. Khawla San, she also here, my student, she worked hard about 1 year to finish this project. And the last project here I want to mention about methane production. We try to produce another way, or to recover the energy by another way, by producing methane or hydrogen, both as a biogas energy can be. So we, in this case, we develop an anaerobic system. We introduced the nanoparticles to the system, and we were able to improve the methane or the biogas production 120% comparing with the regular or normal methods, and the biogas here at CH4 improved 122% comparing with the ordinary technique. So then we, actually when I say something here, that means 1 year work at least, and too much information you can find in the journal, like this also Renewable and Sustainable Energy Review, which has 16 impact factor, one of the top also in our field. So you can visit this paper and you can get too much information and details. So I finished my presentation, but I want to mention something. My lab, along with the EXIS, we organize every year annual international conference, which called International Exchange Innovation Conference on Engineering Science. We call IEICIS. So please remember this one. So this is also Scopus Indexing Conference. I know Egyptian people and researchers are very interested to Scopus things, yeah? And then also more important information is free registration, no money, just come and join. And this year we will have the 10th edition from this conference, 17 and 18, just next week. So I will back a little bit early because I'm the chairman of this conference. And next year we plan to be October 30, 31st, because if we have the KYUDAI now next year, it's better to make it a little bit. Okay, I just plan for next year. And the deadline for submission is July 31st if you are interested. So I would like to thank many Egyptian colleagues here, and I will start with actually Professor Haitham Awad from the Alexandria University. He was the first Egyptian I meet in Japan when I visit to start my study. Thank you, Professor Haitham. And also, I would like to thank Professor Jad because still keep collaboration with us, Professor Ahmed Khalil, Khamis, Islam, and Ahmed. They are from different organizations, and Ibrahim, still we have collaboration. Ahmed Khalil from Cairo University, and currently we have student from Alexandria University, and we have Dr. Ahmed from the Nuclear Material Authority. Thank you so much. If you need more information, please just go to this one.
Thank you, Doctor. I think we can have one simple question. Okay.
Thank you for your very interesting talk. And my question is, what is the scale that the scale and the mode that you can purify the water? Can we purify the water as the aquifer, an underground aquifer, for example, or the tap water, or the river water, or what?
Yeah, thank you for the question. Actually, as I mentioned in this lab scale system, we inject and we simulate the aquifer case. So we can extend this information and apply to the aquifer case. This one, and for the surface water. Also, we develop another system because we don't have time to mention everything here, but I have too much information. So we develop this continuous flow system to treat the surface water. So surface water can be supplied through this system. We have here a reactor, and we have here separator, and we have filter. Then we can get the clean water. This is for the surface water, and the injection of the nanomaterial or building the barrier for shallow groundwater can be applied. And actually, this is in some country, in Canada, they apply the injection technique. Large scale, I think, in Canada, depending on the pollution zone. Yeah.
Okay, thank you so much, Professor Osama. Now for our last presenter before the break, Assistant Professor Ibrahim Ma'moon. He's from Department of Bioscience and Biotechnology, Faculty of Agriculture, Kyushu University. He's going to talk about the potential of nanocatalysts and microwave irradiation in the food industry.
Dr. Ibrahim Ma'moon works as an assistant professor in the Department of Bioscience and Biotechnology, Faculty of Agriculture in Kyushu University. In 2012, he completed his bachelor's degree in civil engineering at Al-Azhar University. He got his master's and doctoral degrees in energy and environmental engineering from the Interdisciplinary Graduate School of Engineering Sciences at Kyushu University in 2018 and 2021, respectively. He worked as a postdoctoral researcher at Japan Atomic Agency, which is Ibaraki, from 2021 to 2023. His research interests include nanocatalysts, food waste recycling, microwave-assisted reactions, and water treatment.
Thank you. Thank you very much. Thank you for being here. Good afternoon, everyone. I'm honored to be here in the first time of KYUDAI now in Cairo. And it's my first personal participation in KYUDAI now. I will try to make it brief so you can enjoy your break. So my presentation is about the potential of nanocatalysts and microwave irradiation in the food industry. This is the contents. So at first I start with my personal background. I got my bachelor degree in civil engineering from Al-Azhar University in Cairo. Then I had a multiple position in Egypt as a hydrogeologist, research assistant, and at the WRRI, the Water Resources Research Institute, and teaching assistant later at Al-Azhar University, my university in Cairo. Then I moved to Japan in 2016 to study master's degree, and I got the master's degree in energy and environmental engineering from Jamal Sensei Laboratory, as he previously mentioned, and the doctoral degree from the same lab. Then I started as a postdoctoral researcher in Japan Atomic Energy Agency in Ibaraki, Japan, for almost 3 years. And then I started this year, January 2024, I came back to Fukuoka to work as assistant professor in the Faculty of Agriculture, Kyushu University in Japan. And these are nice memories from my previous lab in Chikushi campus, Kyushu University. This is my group, our in Advanced Science Research Center in Japan Atomic Energy Agency. So basically these are the keywords of my background, including chemistry, engineering, environment, energy, and material science. But now I'm working in Faculty of Agriculture, specifically in food process engineering. So I'm trying to make a fusion or multidisciplinary between catalysts, microwave, and food waste in terms of preparing nanocatalysts using microwave techniques, and also investigating the catalytic effect of this material in recycling food waste or getting energy from biomass, and also using microwave itself for the digestion and valorization to get energy from the food waste. I will try to make it simple. Of course, I cannot make or present better about Kyushu University than Khawla-san has already did. But briefly about the Graduate School of Bioresources and Environmental Sciences, which I belong to. It has several labs, as you can see, several divisions, and each division has a lot of labs. I will not go into details in that. You can check it on the website of the Faculty of Agriculture, the graduate school. And the division which I belong to, the Bioscience and Biotechnology, they have several labs, and one of the divisions is the Food Science and Biotechnology. They are concerned with a lot of research themes in different labs, like the food hygienic chemistry and food process engineering, which is my lab, the analysis of food, the nutrition chemistry, and the food chemistry itself. So I belong to the food process engineering laboratory, and in this lab we focus on different research themes. These are my sensei in the lab, Professor Igura sensei, and Associate Professor Shuntaro Tsubaki. And for instance, Igura sensei, he is concerned with the emulsion and disperse system, which is very important if you want to use the delivery of the nutrients in food applications, and also the rheology of the food, the properties of the food in terms of controlling the physical properties. Tsubaki sensei, he is expert in microwave applications, and he's trying to use the microwave expertise in food processing and sterilization. And in my case, I also try to use my expertise in the catalysis and nanomaterials to recycle food waste to get energy, and also to prepare a functional nanohybrids. Our laboratory is well equipped for basic and applied research in the food industry and food waste treatment. And also we have a lot of joint research with food and chemical companies in Japan, like Mitsui Chemicals Incorporation, for instance. We have also a lot of joint position actually from Tsubaki sensei, Igura sensei, and even I started a joint position in Qubit this year, and ISNAR, the Neutral Carbon Institute in Kyushu University. So these are the group, members in our lab. We have 2 postdoctoral researchers, international, Bangladeshi and Indian. And we don't have a lot of international students, but I think since I arrived to our lab, even my sensei, they started to tell me, please bring Egyptian students to our lab. So please check this QR code and check our lab, and you are more than welcome to discuss with me about the research teams, and we are really kind of recruiting international students. So please encourage your students to visit our lab website and check our research teams. So I will just try to make it brief. Maybe I will skip a lot of details because of the time. So basically, nanocatalysts, they are either heterogeneous catalyst or homogeneous catalyst. The heterogeneous catalyst, it's kind of catalyst and reactant, they are both in different phases. Like the example of catalytic hydrogenation of ethene on nickel surface or nickel support. In case of the homogeneous catalyst, both the catalyst and the reactant, they are both in the same phase. Like the hydrolysis of sucrose, which is one of the sugar compounds, with organic acid to glucose and fructose. So, of course, nanocatalysts can be applied in a lot of applications, like environmental, drug-derivative related, water purification, and solar cells, energy related. Also, the properties of the nanocatalyst are very important in terms of the composition, oxidation state effect, like the mechanical properties, magnetic properties, the shape and size of the particle itself, and the binding energy, that's very important, the support and the confinement effect in terms of the activation energy and the phase transition. Okay, how about the nanocatalyst application in food industry? So, For instance, I just focus here on food processing and food packaging and sterilization. Nanocatalyst can be used as anti-caking agent to enhance the consistency of the food and prevent any lump formation while we prepare food or process food, like aluminum silicate nanoparticles, magnesium oxide nanoparticles, etc. They can be used as nano additives to improve the nutritional value of the food, like omega-3 encapsulated nanoparticles, for instance, gelating agent like nanogel, nanocapsulation and nanocarriers to protect the aroma and the flavor of the food or carry it. Also the food packaging and sterilization. Active packaging, it's like currently or nowadays we want to substitute the harmful plastic wrapping of the food for fruit or vegetables or whatever. So nowadays we are focusing on providing a biodegradable wrapping and also with antimicrobial effects, so it can prevent the bacteria to form inside the food, which is very important. Nanocatalyst can be used in this regard. And of course, sterilization to prevent spore-forming bacteria in food, as I will mention briefly. Okay, how about the second aspect I want to focus on? The microwave irradiation. Microwave is basically electromagnetic waves, and this spectrum shows you where is the microwave light comparing to ultraviolet light and gamma rays, and also in terms of the wavelength comparing to X-rays and infrared light. So microwave, they are the electromagnetic waves within 300 megahertz to 30 gigahertz. So basically how they work, for instance, irradiation of microwave, they are applied to polar molecules and they cause molecular rotation, or as scientists they call it the vibrating motion of the molecules, which generate the heat, which basically used for application of microwave, like the very simple application which is heating the food that we are eating every day. So comparing to conventional heating, the concept of heating is a bit different. Conventional heating, the outside temperature is usually higher than the inside. But for microwave heating, it's like heating from inside out. That's why a uniform distribution of the heat are generated within the food or within any kind of application we are using it. So in case of conventional heating, temperature rise due to heat conduction. In case of microwave heating, temperature rise due to self-heating because it's inside-out heating. So how about microwave applications in food industry? One of the applications is the sterilization using microwave heating. Like for instance, nowadays in the industry, it's already utilized. This is one of the examples from Japan Hi-Com Corporation. This is a microwave sterilizing system for the sushi rice, the rice that's used in the sushi, and it improved the shelf life of packed sushi using microwave. And also, this is another equipment from France for the sterilization of meat to prevent or to increase the shelf life of meat by using microwave to kill the bacteria in the food. So I will just present hints about some research themes in our lab related to what I just mentioned. So in this research theme, we work on accelerating the extraction of urban by microwave irradiation. I will now explain what's urban. First, there is a blue-green algae called ulva. It's kind of seaweed, one of the species of seaweed, and it habited a huge amount of area from 2 million to 6.8 million kilometer. And also because it's spread around the world, so it can be used as a fertilizer and feed conversion, and if you dispose it, it will be at a great cost. So this algae has a functional polysaccharide called urban, and what we want to do to apply heat to this seaweed, and then we extract the urban, which is the polysaccharide that can be used in different applications like anti-cancer agent, antioxidant, and also it can be used in food processing applications. So we want efficient extraction process. That's why we can use microwave to extract it by heating and changing the conditions. Direct intracellular heating, it will increase the pressure, the intracellular pressure, and then the cell wall will be disrupted and the mass diffusion of urban from the ulva, it will go out, extract. So it will give us higher yields, lower extraction temperature, and shorter extraction times. Of course, it will be good for the cost efficiency. I will not go to a lot of details, but one of them, we will, observe the structural change in this process during the heating of the seaweed using SACs or small angle X-ray scattering for observation of the molecular changes. So, for instance, this is the ulva sample, and we put it in a flask or a cell, and in our lab, it's occupied with different experimental setup to apply microwave, different frequencies of microwave with different power, even from frequency from 200 megahertz, the radio frequency, going through to 915 megahertz and 2.45 megahertz. We have even up to 6.5 megahertz. And of course, we need to compare it to conventional heating if we want to know what's the effect of, or the enhancement effect. So anyway, I will just go briefly. So in this case, the total sugar content after applying the heat and using water as a solvent and of course mixing during the process, the extraction coefficient was very high for the 2.45 gigahertz comparing to the conventional heating. If you don't see the significance, actually it's very high. In case of extraction coefficient, such low difference is very important. So basically what we observed, that the effect of the selective heating of water is higher than the selective heating of microwave to the seaweed itself, to the ulva itself. That's why we observed it using SACs, and the mechanism appeared to be like this. Basically, the microwave is subjected to the water, which is the solvent containing the biomass, and the microwave causes accelerated diffusion of the dipolar water molecules inside the intracellular layer of the algae. And then, because of the heat, the selective heating of the water, the molecules of the urban, they aggregate, and this will enhance the diffusion of the urban molecules to go out in the diffusion phase, which is towards the extraction phase. So that was the mechanism, how the microwave enhanced the urban extraction. This is the second research theme I want to present, the instant sterilization of spore-forming bacteria in food using microwave. Spore-forming bacteria, maybe we all know about it, or even we observe it in food, the food spoilage, in Arabic, al-afan, in food. So, of course, it affects the flavor degradation and loss of nutrients. The nutritional value of the food become less. So, if you heat the food, you kill the bacteria. Usually, they use steam sterilization or dry sterilization. What we wanted to do is to observe how microwave will kill this bacteria in this case. So, of course, we used this chemical setup to apply microwave and the conventional heating, and then, of course, we use the spore suspension, and then we do the inoculation and the incubation and the colony counting to see how much spores are killed. And of course, we observe the spore damage using the BI or the DABI fluorescence staining using the microscopic observation. And actually, we also conducted a real-time PCR for the heat shock protein-related gene expression, but it will be a disaster if I explain it now because of the time. So basically what we observed, a bactericidal effect of microwave. The microwave killed bacteria much better than the conventional heating, and also it gave higher temperature. And it was also observed when we increased the microwave power, the spore damage was increased comparing to conventional heating or even the control sample. The mechanism, what we observed, how the microwave killed the bacteria. Basically, the spore shell, it's composed of protein. Of course, this is what we observe after conducting the real-time PCR for the proteins inside the bacterial cell. The spore shell, composed of protein, is destroyed because of the alteration of the proteins inside the cell because of the heating of the microwave. And the heating of the core, because of the shell is destroyed, the heat reached the core. So the cortex protein also were altered, which is important for the vital functions of the bacteria. The bacteria needs the core protein to live. So if they die, the bacteria die. And in case of the conventional heating, it was difficult to conduct the heat from the spore shell to the core. Sorry. So anyway, microwave was much better than the conventional heating. The last research team, how about killing the bacteria using microwave and a heterogeneous catalyst? So if we add a heterogeneous catalyst and selectively heat the catalyst, this will enhance even the killing effect on the bacteria. So first we screen different catalysts, and then we apply the microwave heating, and then we apply the activity test for sterilization of Bacillus subtilis. So we observed a lot of catalysts, one of them titanium dioxide, activated carbon, tungsten oxide, cobalt, copper, manganese oxide composite, and all of them, they have a good microwave irradiation response. And we use this experimental setup, which is in our lab also, to apply the microwave heat to the catalyst, the material that we prepare. And also we use this setup to measure the dielectric properties of the material. Dielectric properties is basically how much response the catalyst or the material will be, how much the material will be responded towards heating with microwave. So the higher the value, the better it will be selectively heated by microwave. So we conducted the catalyst screening and we found activated carbon, one of the material that we tested. It has a high heating property by microwave, fast temperature increase, and also when we supported titanium dioxide on activated carbon, it even gave over 3 times improvement. So it shows a good potential to be heated by microwave. So we conducted the activity test on the inactivation of the spore-forming bacteria, and we found that the titanium dioxide supported on activated carbon when it's heated at 2.45 gigahertz microwave heating. It shows up to 7 log reduction in the number of the bacteria, which is very, very promising results. So concluding remarks for the research teams, the accelerated organ extraction from the algae biomass, microwave enhanced that, achieving maximum of 45% yield rate, which is very good comparing to the literature. And basically the reason was the selective heat of water, the solvent in this case, which enhanced organ extraction. Also, the microwave enhanced the sterilization of the spore-forming bacteria by distracting the spore shell and reaching the heat to the core, which damaged the vital proteins for the bacteria. And also, applying the microwave heating with catalyst with high microwave response gave nearly 7 log reduction in killing the Bacillus subtilis bacteria. Finally, I will just want to conclude. This is some of the ongoing KYUDAI and Egyptian researchers collaboration. For instance, this is one of the ongoing work now to investigate behavioral factor behind water conservation and consumption, considering the current water crisis we face in Egypt, which is very important for everyone. One of the collaborators is from the Egyptian Environmental Affairs Agency, Ministry of Environment, Dr. Shaima Abbas, and also one of our previous lab mate in IGSIS, maybe Khawla-san remember her, Singa-san, and of course Professor Osama Jamal and myself, and also this is another research to utilize biodegradable nanomaterials for groundwater treatment. One of the collaborators, one of my previous professors in Al-Azhar University, Professor Rani Fouad, and also one of my colleagues from Arab Academy for Science, Technology and Maritime Transport in Egypt, Dr. Muhammad Magdi. And also this is like international research team. Now we are trying to apply for a GSPS fund or even GST fund to work on innovative application of microwave irradiation and food waste recycling within microbial fuel cells. The collaboration are from Egypt, also Professor Ian, maybe Osama Sensei mentioned about it, from University of Oxford, Osama Jamal Sensei, and also Tsubaki Sensei from our side in the lab, and myself. So that's all for my presentation. Thank you so much. Sorry for taking the time from your break.
If we get rid of the bacterial contamination from food, what about the heat-resistant exotoxins?
Yeah, that's right. Actually, this is one of the work now we are working on the lab, because of course the heat-resistant bacteria, they will not be affected. That's why we want to add the microwave with the catalyst.
But I think they will be, all the bacteria will be affected by conventional or microwave. But the exotoxins, the problem is the exotoxins.
You mean the exotoxins after the bacteria?
Yes, yes.
Okay, in that case, that's why we add the nanocatalyst. The nanocatalyst itself, after the selective heating of the microwave, it can eliminate the exotoxic by absorbance from the food. That's what we want to develop now in the lab. And that's actually the main reason why we are conducting or fusing the nanocatalyst with the microwave, because using the microwave itself, it can kill the bacteria, but we are afraid about the exotoxins. That's right. So nanocatalyst can, if selectively heated, it can absorb the exotoxins. Thank you for the question.
Any more questions? Okay, thank you so much, Dr. Ibrahim. Now we have around 30 minutes of break time, and we can come back again by 4:50. Okay, we have our first speaker, Professor Jimmy Jiro, from Faculty of Dental Science, Kyushu University, is going to do the introduction of research being conducted at Kyushu University, Faculty of Dental Science.
Professor Ijuru Jimmy is a chairman in the Oral Health/Brain Health and Total Health Research Center and the Vice Dean for the International Affairs at Kyushu University, Faculty of Dental Science. His research focuses on understanding the molecular mechanisms of bone metabolism and oral cancer. Professor Jimmy is actively involved in educating dental students and fostering the next generation of dental researchers. He is committed to advancing oral health science and contributing to global dental medicine through both education and research.
Okay, good evening, everyone. So my name is Kyushu Jimmy. I'm Vice Dean of the Faculty of Dental Science and also the Oral Health and Brain Health and Total Health Research Center. First of all, so I'd like to thank Jimmy Sensei and Oki Sensei and other organized staff to give me a chance to introduce our research and also the Graduate School of Dental Science. So is there any dentist here? Only two. He is the alumni of our graduate school, and also I was one of the reviewers of his defense. So that maybe most of people is not interested in my presentation, but my mission is to okay. Thank you. So that so my mission is to recruit the international students from the North Africa areas, but particularly Egypt. So that, and also I bring that movie regarding to the graduate school. So and also the end of part we have that in our dean's message. So I have to finish my presentation within 10 minutes. Okay, so let's start. Okay, so the Kyushu University Department of Dentistry is established at the Kyushu Imperial University in the School of Medicine. And it becomes independent in 1967. And we celebrated the 50th anniversary in 2017. And also the Graduate School of Dental Science was established in 1974. And the Faculty of Dental Science was established in 2000. So based on so since 2000, we have been working to enhance education and research and dental care under the philosophy of the oral health, overall well-being through oral health. And based on the latest student data, so we have 169 students in our graduate school. So about 40% of students are international students. The most of the from that in the China and the Middle East, and also that in the North Africa, Egypt and Sudan. So these one representative of our international students. Okay, so we were selected in the government-sponsored PhD program in 2022, and actively accepting international students from the Middle East and also the North Africa. So we received many applicants from the Middle East, but not in the North Africa is not much. So, and we have recently applied a new continued development this program for 3 years from the 2025. So we have not yet known that this program is accepted or not, but it's important thing that to inform you that we try to recruit the international student from North Africa area. So we offered the 4 years PhD program for the student who would like to join our graduate school. And the student need to meet the admission requirements to apply our PhD program. Please visit our homepage for the detailed information about the application requirements and deadlines. And this slide shows that in the course necessary for applying to our university. So this is not in only the dental graduate school. So all the common graduate school, the cost. So that the student can also apply the tuition and the enrollment fee waiver if you meet the necessary requirements. And also recently the Japanese yen goes down, so it's better to come, easier to come to Japan. So in general, so the students, international students mainly do research at graduate school. So, however, if the student would like to visit the Kyushu University Hospital to watch the clinical practice, they have to make necessary applications through the supervisor. But if you are planning to the practice in Japan, dentistry in Japan, it is a little bit difficult because you have to pass the Japanese dentistry national examination. And particularly you have to understand Japanese and also writing and speaking and listening and reading. Reading is with Chinese character, so this is very hard thing that. So since the Faculty of Dental Science is established, we have focused on the oral health science and oral tissue regeneration and reconstitution research. Then, so in 2016, so oral health, brain health, total health, so-called OBT Research Center was established, and I became a chairman in 2017. And also 2021, in the dental craniofacial development and regeneration, so-called DDR Research Center was established, and Professor Fukumoto is become chairman. So first, I'd like to introduce that about concept of the OBT Research Center. So we have investigated in the relationship between these three functions: oral health and oral function, brain function, and the total health, and also how it leads to overall well-being through oral health. So this slide shows the ongoing project at OBT Research Center. Today, I don't mention about each project in details. Please see the details in our homepage. But let me introduce some of them. So that Dr. Yasukochi, she's conducting research into the effect of a maternal environment during the pregnancy on the postnatal growth and development of the child, known as a DOHAD research. Recently, she has shown that in the intake and the high-calorie diet, during the pregnancy, lead to change the PYGL genes. So this is the important enzyme to produce the glucose from the glycogen. So this one has a mutation in the offspring, and then in the offspring that in the glycogen is accumulated in the liver, and then due to the obesity and also the metabolic disorder. So Dr. Sanematsu is working on the molecular mechanism. So how we feel the taste, sweet or bitter, and sweet, sour, or something like this. And then so recently, so he conducted the mathematical analysis of the structure changes that occur in the sweet taste receptor when the human specific sweet substance scromate bind to the receptor. So his research may contribute to the improve that in the insensitive that taste during the ages. So let me move to the DDL Research Center. So at this research center, we focus on developmental biology and biomaterials and using this biomaterial for the clinical research, and also the stem cell therapy, and also that in integrated the management of the big data and bioresources. So Dr. Hayashi developed the carbonate apatite with a honeycomb structure. So you know the honeycomb, okay? Then he succeeded in inducing the bone formation effectively by applying the drug that promotes bone formation to the pores. So his research is that very useful for not only the dental field and also orthopedics field. And Professor Fukumoto is famous of his tooth development research. He has comprehensively analyzed the changes in gene expression when the epithelial cells stem cell to the differentiated ameloblast. So, and also that he found that several genes important for the ameloblast differentiation, and he knocked out. And then the phenotype is the tooth development disrupted. And also another important interesting thing that in the hair is also differentiated from the epithelial stem cells. So that means that in the balance of some gene expression changes the tooth to the here. So maybe that his research is also that important for not only the dental fields, for the elder man. Okay, so in the future, so we will concentrate the research conducted in the Faculty of Dental Science into two research centers and to aim to realize overall well-being or through the oral health. So we have more than 20 different departments focusing on the different areas of highly specialized research in the dental field. So please visit our homepage for detailed information about our graduate school and research we do. So if you have any questions, please contact at this email address. Okay, thank you for your attention. So I show you that in the movie.
Kyushu is located in the southern part of Japan. Fukuoka is located at the northern part of Kyushu Island. Fukuoka is a land of many beautiful wonders, both natural and urbanized. It is also a very exciting city and is one of the fastest growing cities in Japan. Tenjin, Nakasu, and Hakata are some of the main areas in Fukuoka. There are many bars, cafes, restaurants, and shopping malls here. Kyushu University is located in Fukuoka. Kyushu University has 5 campuses, and our graduate school of dental science is located at the hospital campus. We are located right next to Kyushu University Hospital. This also means our campus is easily accessible by all kinds of public transport. The closest subway station to our graduate school is Maidashi KYUDAI Dorian Line, and you can get to our campus in less than 5 minutes from the station. We have a lot of international students at our graduate school of dental science. About 30% of our graduate students are international students, and we have many students from Asia and the Middle East.
Hi, my name is Freitas from Brazil, and I am a student here at the Graduate School of Dental Science in Kyushu University, here in the Laboratory of Biomaterials. In this laboratory, we specialize in making biomaterials for dental and orthopedic applications. So we have many international students in our laboratory.
There are a lot of student facilities on our campus. We have the medical library, which has a collection of more than 300,000 number of books. Our campus is full of greenery, and there are various sports facilities like tennis courts, baseball field, and gymnasium that students may use. Our student cafeteria serves all kinds of delicious food, like ramen, udon, and set lunches at affordable prices. Near the campus, you can find many convenience stores and restaurants. At our graduate school of dental science, we provide lots of space for students to interact and do their self-study.
Would you please introduce yourself?
Yes. My name is Ma Jialo, and I am from Shanghai, China. I'm a third-year student of Kyushu University Graduate School of Dental Science. My research is based on preventive and public health dentistry.
There is a lot of interaction between Japanese students and international students on our campus. This is a message to you from one of our Japanese students.
Hi, I'm Tsukasa Yuki. I am in my third year of PhD course at Kyushu University, Graduate School of Dental Science. I'm currently doing research on nuclear factor called light chain enhancer of activated B cells and periodontitis. There are many students from different countries here at Kyushu University, and I enjoy working with them. My message to the international students is there are some tough times, but the experience here at Kyushu University is very, very valuable, and I assure you that it will help you with your future career. I am looking forward to meeting you.
My name is Kyushu Jimmy. I'm professor of the research center. Kyushu University is a good place for research. We welcome international students. Please join us at Kyushu University.
At Kyushu University, we provide comprehensive support for international students. This includes the supporter program and support from administrative staff.
Hi, my name is Yasukochi. I am an associate professor from Mobility Research Center.
Hello, my name is Lynn, and I work together with Yasukochi Sensei on International Affairs. We are both head of the International Office of the Graduate School of Dental Science.
We hope to have more international students at our graduate school, and we are trying to increase the partner university we have.
My job is to support the international students at the Graduate School of Dental Science. Students come to me when they need to renew their visas or if they face problems with their daily lives in Japan.
And so, what are your plans after graduating here from Kyushu University?
Actually, I would like to work more in fields related to my research, and I want to improve my research skills. Basically, you can say that I want to further my knowledge to make the most of my experience here at Kyushu University.
So, do you have any advices or kind of messages for students that want to join Kyushu University?
I want to say that challenge yourself, make goals and work toward them. Work hard and enjoy your success harder. And finally, the most important thing that don't give up on your dreams, because eventually they will come true.
Hi, I am Nishimura, Dean of Kyushu University Graduate School of Dental Science, and one of the 10 national universities designated by the Ministry of Education, Culture, Sport, Science, and Technology with capabilities to develop world-class educational and research activities. Kyushu University is a leader in research in both Japan and the world. Based on the belief that oral health contributes to the overall well-being of the general health, Kyushu University's Graduate School of Dental Science has developed advanced research concentrating on oral health science research and oral tissue regeneration and reconstruction research. In order to further promote these activities, the Center for Oral Health, Brain Health, and Oral Health, also known as OEP Research Center, was established in 2016. This center focuses on doing comprehensive research on the relationship between oral health, brain health, and total health of the elderly. In 2021, we established the Dental Craniofacial Development and Regeneration Research Center, also known as the DDR Research Center, for the purpose of realizing, regenerating, and reconstructing medicine of oral tissue. Under the excellent guidance of our faculty members, our graduate students motivate each other working on their research, and they have achieved outstanding results and won many national and international awards. Furthermore, we also established a master's degree program in 2023 in order to cater to a larger audience. So, please join us at Kyushu University Graduate School of Dental Science. for welcoming me to our graduate school.
See you at Kyushu University. See you at Kyushu University.
See you at Kyushu University.
Thank you for watching. Thank you very much.
I guess we only have time for one simple question. Anyone has a question? Okay. Thank you so much, Professor Jimmy Ejiro. Our next speaker is Associate Professor Moriyama Tomohiko from Kyushu University Hospital. He's going to introduce bridging borders, bridging gaps, how telemedicine reduces health disparities.
Dr. Tomohito Moriyama is a gastrointestinal endoscopist and the director of Telemedicine Development Center of Asia at Kyushu University Hospital. For more than 20 years, he has been keen on advanced diagnostic and therapeutic endoscopy and has shared his knowledge, experience, and techniques with more than 150 Japanese residents and 250 foreign trainees. Since 2016, he has been involved in telemedicine projects which have spread worldwide dramatically through the pandemic. He is committed to reducing global health disparities through effective medical education that combines telemedicine with on-site training.
Okay, hello everybody. This is Tomohiko, endoscopist and gastroenterologist working for Kyushu University Hospital. As a medical doctor working at University Hospital, I would like to be a kind of scientific researcher, but today my talk is totally different from the academia, so I'm just a kind of storyteller today. So I'd like to talk about the telemedicine at Kyushu University Hospital today. So before starting my presentation, I'd like to introduce our hospital briefly. Kyushu University Hospital is one of the largest and oldest university hospital in Japan, having more than 1,200 beds. There are 36 medical departments and 12 dental departments there, and around 3,400 staff working for Kyushu University, and we have more than 10,000 surgeries in a year. Okay, let's go to my topic. Nowadays, it's quite important how to tackle with non-communicable diseases, so-called NCDs. Around 41 million people die from NCD every year. That is almost 71% of all deaths in the world. So it's very important to think the measures against NCDs, such as cardiovascular diseases, cancer, pulmonary diseases, diabetes, or something like that. Okay, this is the data of Egypt, right? Just like quite similar with the global trend, most of the patients die with non-communicable diseases like that. And the top cause of death is ischemic heart diseases, cardiovascular disease, of course. It's followed by stroke, liver cirrhosis, kidney diseases, hepatic cancer, and blah, blah, right? But when we look at the detail of NCDs, we can see that somewhat different view like that. In developed countries, the NCD-related mortality under the age of 70 is very low. But in other countries, especially in developing countries, it's a bit higher. So we can see the quite a distinct disparity in that field. So we can understand the tackle against NCD, especially focusing on younger ages, is quite important. So based on that situation, Japan has a longer life expectancy compared to the other countries like that. So this is also about data about the age standardized cancer incidence and the mortality. Because Japan is a kind of hyper-aging society, so comparing to the globe, the incidence of cancer is a bit higher. But when focusing on its mortality, comparing its incidence, mortality is low, like that. So when focusing on the gastric cancer, it's a kind of my specialty. Japan, the gastric cancer incidence is very high, but its mortality is around 1/3 of its incidence in Japan. But in other countries, the gastric cancer mortality and the incidence is almost the same. It's totally different, right? So why Japan has so good result of the major second neoplasia and other diseases? So that this is just my opinion, but one, we have many healthcare providers, including public ones and private ones, and regardless of its and also our medical cost is very cheap compared to the other countries, and the medical cost is same between private hospital and public hospitals, and also we only should pay 30% of the medical cost, because now about other 70% will be covered by national health insurance system. And furthermore, we have a good and cheap health checkup systems. Based on this situation, we can diagnose the diseases and treat it at early stages. And we have a lot of good medical equipment companies, so that new modalities and equipment is also available in Japan. So, but I would like to emphasize the importance of education. We have shared our knowledge and experience on diagnosis and treatment among doctors. So this is just an example of our university. Based on, we always make some discussion with an expert, and also all the endoscopic images taken by young endoscopists is reviewed by us. And also we have a lot of good simulator, and also we sometimes organize some kind of medical training for young doctors. So to know our way of education and also our way of diagnosis and treatment, many foreign doctors would like to visit us to learn from us. Of course, we are more than happy to share our knowledge and experience with those kind of people, so that's why we have accepted more than 600 medical doctors from various countries, mainly from Asia, but also from the other areas. So I myself is an endoscopist, and my former boss, Dr. Shimizu, is a surgeon. So that's why our activities mainly focus on gastrointestinal cancer or something, but also other departments such as ophthalmology, pediatrics, or other departments also have accepted many foreign doctors. And also we sometimes go abroad to do some on-site training in various countries, like that. This kind of human exchanges is quite effective, of course, but unfortunately, it's unsustainable due to its time, and also we should think about the cost to keep on this project, and also very limited doctor have a chance to come to us, and also for ourselves, very limited doctor can go abroad. So we started telemedicine activities around 2003 to connect many institutions all around the world. So at the time, in this picture, you can see the two Egyptian doctors here, one in Japan and one in Egypt. The doctor is from Al-Azhar University, so that we are more than, we made a very fruitful discussion at the time to expand our telemedicine activity to the world, we have organized many domestic workshops in various countries. This is a place where the doctor and the engineer get together and share the knowledge, and also they recognize the usefulness of telemedicine there. Unfortunately, there is no Egypt so far, but we hope to have this kind of workshop in Egypt in the future. So, and also we have expanded our this kind of telemedicine activities with China, Latin countries, Caucasus, and Africa. Also, for medicine, of course, the knowledge and experience is quite important, but sometimes technique is important, especially for surgeon and endoscopist. So the live demonstration is quite a popular program in the Congress, especially in the foreign countries. So, but usually, the organizers should invite the many foreign faculty to the venue or the hospital near the venue. They do the foreign faculty do some advanced therapy or diagnosis in that hospital, and that the images will transmitted to the venue. It's a kind of a usual live demonstration in the Congress. But we did some remote live demonstration to make it more comfortable, especially for foreign doctors. In usual setting, foreign faculty should do their live procedures with totally different atmosphere, with totally different staff, with totally different equipment, and sometimes we feel some jet lag, or sometimes there is language barriers between the medical staffs. So, but in that situation, they can do their procedure at their hospital. It's quite comfortable for this kind of foreign guests. And also quite good for organizers, because they don't need to collect the patient for this kind of live demonstration, and no need to get some approval for medical license from their government. So these are our contents. So like that, of course, the endoscopy and the surgery is the top two contents, but we have a variety of programs like that. During the COVID-19 pandemic, we cannot go anywhere, right? Of course, you remember that. At that time, no one knows what is happening in Asia, right? So this disease came from Asia at the time. So we make an international tech conference on COVID to discuss how to protect medical staff from these new diseases. So we organized this conference 3 times in early 2020. So that many countries joined our discussion and shared our knowledge and experience about the tackles against these new diseases. So more than 4,000 doctors and medical staff joined in total. But of course, the COVID pandemic is very, very big issue for us. But that situation about telemedicine was totally changed. Because in almost all the countries, the internet situation was dramatically improved through the pandemic. Before the pandemic, we cannot make any fruitful discussion with good view images with some rural countries like Bhutan, Myanmar, or something like that. But in those countries, internet situation was improved. So nowadays, we can communicate each other quite easy. And also, other equipment, especially the telecommunication system, is also dramatically improved. Before the pandemic, to do the live demonstration I showed, we prepared a lot of engineers with complicated system. But nowadays, we just need one engineer with very simple system like Zoom, WebEx, right? So it's quite easy to share the techniques of the endoscopist via internet. once we can get this kind of a quite simple and easier system, we can do a kind of a reversed live demonstration, right? Usually, live demonstration, the expert provided their techniques or knowledge to trainees. But in this situation, trainees provide or show their technique to expert. In this photo, the endoscopist in parallel doing some endoscopic procedure. And this endoscopic view and the operator's hand view is sent to Australian doctors. So he is one of the endoscopy experts in Australia. He making some advices during the procedure. Okay, so then our telemedicine activities, this is a number of our telemedicine activities. Even during the pandemic, the number of the programs didn't decrease like that. And also, so nowadays many institutions would like to join our program. So far we have organized more than 1,900 events with 1,600 institutions in 83 countries. Okay, so watching to health target progress in Egypt. Based on the great effort of the European government, universal health coverage is improving like that. But unfortunately, healthier populations in Egypt is a bit decreasing. That is a big issue. So that's why many Egyptian doctors would like to learn more to change that situation. And also, luckily, we have that means the Kyushu University Hospital has accepted 11 clinical trainees from Egypt since 2008 in various fields like pediatrics, endoscopy, oral surgery, or cardiology like that. So nowadays we are luckily having an EGM program, Egypt-Japan Education Partnership. So just before the pandemic, we had accepted 3 Egyptian doctors in surgery, endoscopy, and oral surgery, like that. So it's now is a very great opportunity to strengthen our collaboration between Egypt and Japan. So this is my taking home message. The telemedicine is useful for sustainable medical education, and nowadays we can share medical knowledge, experiences, and techniques among countries on a daily basis. And telemedicine can contribute to filling local, regional, and global medical gaps. Thank you for your kind attention.
Any questions? Thank you so much, Dr. Tomohiko. Before our closing remarks, we have one last speaker, Dr. Oki Yutaro. He's a project associate professor at the J. Mina office, International Affairs Department at Kyushu University. He's going to talk about history of international law in Egypt and Japan.
Dr. Yuki Otaro Oki Yutaro, I'm so sorry, has graduated from Kyushu University Faculty of Law in 2009 and completed the master's and doctoral programs at the same faculty. After 6 years as an assistant professor and lecturer at the same faculty, he has been at the position of an associate professor and manager of J. Mina office, Global Strategy Office of International Affairs Division of Kyushu University.
Thank you very much for your kind introduction. It seems all of you are very tired, so just 15 minutes more. This is very last presentation. And actually I prepared with Professor Tan and others this program, so I know no lawyer here and no historian here. So no colleague of mine is here. So I will not really talk about the real law things. I don't talk about any legal interpretation, for example, the civil law or criminal law. I just touch on some possibility of comparative studies relating to international law, which is my field of research. But before doing that, I'd like to talk about myself. I think many of you, or some of you have received the MEC scholarship to come to Japan, or the fund of JSPS to come to Japan. But I think no one has received the Egyptian governmental scholarship to study in Egypt. But I'm the one. When I was undergraduate student, أنا أخذت منحة حكومة مصرية وجعلت مصر يعني 2004 لا 2005 حتى 2006. Just 1 year, so my Arabic is getting worse and worse. So anyway, I didn't finish my presentation. But anyway, after enrolling School of Law, just 1 year I stopped the study in faculty or School of Law, and I decided to come to Egypt. And the one reason of it is, of course, I was interested in the Middle Eastern politics at that time. You can imagine why, because of this year or that year, 2011, 9/11 or Iraqi war, but at that time. But more strongly, it's a kind of the historical connection. I think it's a very old friend of Professor Katz. At that time, there was a professor called the name Otoshi Sensei, Professor Tetsuya Otoshi. He was a professor of faculty of later of Kyushu University, and I think one former dean of the JSPS Cairo Center. His lecture in Kyushu University was very interesting, fun, about the Egyptian society or the history of Egypt, especially for modern era. Then I asked him, I'm interested in the Middle Eastern politics or such kind of things, and he recommended me, there are 3 chances or 3 scholarship opportunity. One, Kuwait, another one, I don't really remember, Saudi, and the last one was Egypt. So he put 3, but by himself he omitted these 2. And so he recommended me to Egypt, and I'm also happy. I was also happy. So I came to Egypt and I stayed in 1 year. And if I talk about my stay in Egypt, it takes very long, but I was living in the Hadaiq Ma'adi, Matba, Oral bin Dar Salam. I still remember the address of it. So, but anyway, after returning to Faculty of Law, I faced a kind of the distress period to choose a specialty. I will talk about it later again, but the research or study in the Faculty of Law or Faculty of Letters usually a bit different from scientific field. We are not working in the lab basis. We are more like an individual interest base. So I have to choose my own specialty. And I was wondering I should choose constitutional law or comparative law or legal history or something like that. But I think it was a 3rd year of my undergraduate. I had a chance to visit Gadaref in Sudan with the support of the one Japanese NPO, and he's also the alumni of Kyushu University. And visited Sudan, and I stayed at the hospital of the malaria treatment for 2 weeks. Not because of I was malaria, but to support their activity. And because of that kind of experience, I decided to study international law. Basically, this one shows you the characteristics of the research at the Faculty of Law. But these things I already talked. It's based on the interest of individual researcher. So even after I choose I will do international law, I still have to choose what kind of topic. International law covers sometimes too wide field. Studying, for example, the investment or the war, self-defense, economic law, fishery, and the history, many things. But when I was preparing the graduation thesis, there was I found one interesting case, international litigation, about the Hanish Island case. Some of you remember this case? Hanish Islands, do you know? Okay. It's near from you. Hanish Island is just a small island between Yemen and the Eritrea, so at the end of the Red Sea. So it was a territorial dispute between Yemen and Eritrea. So I don't really remember the history of it very well, but firstly I think Yemen occupied, then Eritrean army entered, and some military accident happened. Then after the negotiation, international litigation started. And this case was interesting for me because in the territorial dispute, for Japanese audience, you can just imagine the case of Senkaku or Takeshima. In territorial dispute, each party should go back to the history. For the case of Takeshima, for example, we usually talk about the Edo period, 1600 or something. So in this case also, Eritrea and Yemen talked about history. Beyond the Ottoman Empire era, Yemen especially made a discussion about the Rasul dynasty, 13th century dynasty in Yemen. And the core issue in this case was court was requested by the party to judge or evaluate the meaning or value of the governance of Rasul Empire or Ottoman Empire from the view of the current international law. It must be, or you can easily imagine, it's logically impossible. Because international law is just a creation of 19th century. But so I will not really talk about the how court decide this case, but this case was interesting for me is the different types of the governance or different types of the states or different types of the law should enter to the field of international law. So by this kind of background, I started to study history of international law, especially with related to Egypt. And but one of the reasons of it is because I studied in Egypt for a while, and it was just only for study of Arabic language, so I didn't study any politics or something like that. But after finishing my study in Egypt, of course, personally, I wanted to connect the experience in Egypt and my international law research. So I was searching and a good topic. Then, but in addition to that, in the faculty of Kyushu University Faculty of Law, especially international law, there's a kind of the de facto tradition. We usually, the professors of the Faculty of Law, International Law, study the history of it, at least as a part of their various studies. For example, they are more focusing on the textbook, old textbook of international law. I think the moderator, you are the Japanese language department. Can you read it? You cannot. Yeah. It's normal. Because it's Chinese actually. This one, the top one, is the first international law textbooks published in Japan. It was 1863 or 62. But how it happened is that firstly, priests in China translated the American international law textbook into Chinese. Then, because of the crisis we had at the time in Japan, Japanese government imported this book and published it again. Then, soon after that, Japanese government started to send some students to Holland or Netherlands or Germany or such countries. Then after their return, they are required to translate or to summarize their experience. So this seems, maybe it's not same for you, but yeah, it's the same title, all say the Bangkok Kobo. This was a summary of the experience of, or the summary of the international lecture they had in Netherlands at that period. So this kind of research was usually conducted by Kyushu University professors. And it was very strange experience at that period because in the international society we have many problems, environmental issue, economical issue, war. So, but this faculty is sometimes focusing on history. Yeah. But there is a reason, but yeah, it was somehow strange things. But since the turn of the century, international law faces or see the big change of the trend of the study itself. So as it is written here, now it was at that time it's getting clear that more intention or more interest in the history of international law is shown by the publication of magazine or a series of the books or like that. But after reviewing these researches, we realized that we don't have any serious research about the early history or the process of reception of international law in Arabic-speaking countries. For example, as I showed you, we have various or too many previous research about Japan, China, Korea, or even Vietnam, or Latin American countries we have. But in Arabic-speaking countries, we didn't have. And and also, even if we have such kind of history or historical so-called study, there's a kind of the tendency to write a history leading to present international law. For example, there was a common tendency to write some, for example, Islamic international law. Sometimes it is called so. The seal, we must have in Hanafiya. There is a kind of the branch called seal. It's sometimes related to similar to international law. So one group of the researchers said this concept of international law, Islamic international law, affects the writing of the Grotius, the father of the international law. But there is no proof. So if we write a history without a proof or evidence, it's just a story. So we should avoid it. So my research is actually it's about Egypt. So even the list of the publication relating to international law in Arabic languages is not clearly shown. So by using the various sources that are put just next to us here, I made a list of the international law publication on 19th century. So I will not really touch on these all, but even from this table, I think it's too small for you to read. We can find some characteristics. Firstly, it's not really related to this table, but do you know Muhammad Ali Pasha sent? This is not a question. Sorry. So do you know when the Muhammad Ali Pasha sent the batches of the students to Europe at first? Do you know when? 1820s. Yeah, true. Yeah, and actually it was 81-6 was the first timing. But the biggest one is 8020, not the biggest, but the famous one is 8028, because Rifat Tahtawi is one of the member of it. So if we know this information, the interesting thing is, at least Rifat Tahtawi, or some documents said, in the group of the Rifat Tahtawi, there is one student studied international law in France. But there is no publication before 1872. So 50 years we had. But remembering the history of Japanese international law reception, just in 1 year, in 1 year, Japanese government asked that student to publish the record, the lecture. But Egypt didn't do so. And also, second thing we can find from this table is it's a bit hard for you to read here, but for example, the name of this one, the translator, Tarablus, Boutros Tarablus, or it's published in Beirut, and here, Umumiya Press, Matbaa Umumiya published 4 books, and the Hirad also published 2 papers. So all these and some writers are Syria, Lebanon immigrant to Egypt at that period. So let's say that only 2 are published by Egyptian, but the others are published by Syria Lebanese immigrant. If you are familiar with Egyptian history, there was a big debate between the Ahlam or the other papers and the Egyptian paper like Moyent or so. So that we can find in this. So in other words, Japanese reception of international law was quite state-centric, but the Egyptian one is more private. So this kind of thing we can find. By the way, this is a photo of the first international textbook, the very big one, the comprehensive one, written by Egyptian international lawyer. You can see the name of it, Ali Mahir Pasha. So, of course, you know the Prime Minister of this country in the 1920s and the 30s. So we don't have such kind of people in the history of international law in Japan. It's also the difference. So I'm speaking a lot, so I will not talk a lot more, but I just want to touch a bit. I just want to introduce one more. So this is the copy of the first international law textbook published in Egypt. Firstly, it was published in French, and translator translated into Arabic. But before saying but, so the background was it was created by the order of the Khedive Ismail. So it's an order from the state. And the author was Charles Pomeroy Stone. He's a United States official, he was a veteran of the Union officer during the Civil War of the United States. So in Japanese, he's a oyatoi gaikokujin, or the employed foreigner in Egypt. So he wrote this book in French, and the translator is Muhammad Osman Jalal. If you like the old Egyptian theater or old Egyptian play, you may know his name. He is sometimes called the father of the modern Egyptian theater. So he's not a lawyer anyway. He was the pupil of Rifat Kafkawi, but more working on the field of letter or literature. But he translates this book. So actually, my research, I will not show you because it takes time, but this characteristic combination gave this book characteristic feature. So I can find this kind of characteristic in each book. I will not talk to reduce the time. So just a summary, just for future. As I showed you very roughly, we may expect the fruitful comparative studies between Egypt and Japan. We have some kind of similarity, like modernization started almost same period in Egypt and Japan. Or actually, Egypt is a bit earlier. You started, if we count from the Muhammad Ali Pasha, it started 1805 or like that. But Japan started after 1860s. Yeah, but anyway, similar period we started. And we faced a similar issue. Like in your country, maybe it is a math, yani. Anyway, the consular, yeah, I don't know. You have many foreign court, and you made to solve it, you made a mixed code, yani mahkamah mukhtarata. Yeah. So it's too small for you, but and maybe Egyptian people don't know him, but this white-haired man, someone know him? Japanese usually should know him, Hara Takashi. And one of the famous politicians of Japan, and he was chosen to the prime minister from the normal level of people at the very first time. But he was assassinated. And it was the starting point of the Japanese way to the war. I mean, the World War II. But anyway, when he was young, he wrote one book about the mixed code of Egypt. Yeah, and this is because he wanted to use the experience of Egypt to solve the same issue in Japan. And he submitted this paper to Okuma Shigenobu, the top politician of that period, and he wanted to do same like Egypt. And many Japanese people against it. And some Japanese threw the bomb to Okuma Shigenobu, and he lost his leg, and all this plan finished. But anyway, we had this kind of similarity. But we, at the same time, we can find the various types of the dissimilarity, as I mentioned in my presentation. So, but this kind of dissimilarity is a good point to focus. So we can find what the background of the development in Egypt and what the background of the development in Japan, and we can compare it. If we do so, maybe we can think about a more global history of international law, or more, let's say, nuanced history. That history will be not the European-centric or not the old-fashioned one, so it could be an interesting thing to do. Yeah, that's all. Thank you very much.
We have time for one simple question. Okay.
Thanks, Professor Oki, for this nice presentation. Actually, I don't have exact question, but I can see my feeling after my study in Japan and my return back to Egypt and working with Japanese people and Egyptian people. I can see when I hear international law, what is happening in the world right now. So, the most two countries I think in the world are working for the peaceful world is Japan and Egypt. So please do your best to continue this message to the world, the whole world. You are doing actually something very, very great, Egypt and Japan. So thanks a lot for your efforts. Thanks a lot.
Thank you very much. Thank you very much. Yeah, but I should mention just one thing. Actually, maybe I mentioned something like Japan started the reception of international law comprehensively or earlier than Egypt. But you know what happened in Japan? Yeah, we created a new theory of international law called Great Asian in Japanese Daitowa Kyoeigen, and it leads us to the war. So you know that's also the point we should consider.
I have a question. When the international law was translated in Ottoman dynasty?
Firstly, it started early. The first one, it was not the full one, but the first book published on the newspaper, age 1807. And after that, middle 90s, they have a lot of books.
So are there any influence from Ottoman dynasty to Muhammad Ali time?
Yeah, good. Not Muhammad Ali time, but at the Ismail time we had a lot because for example, the Hassan Fehmi, one of the prime minister of the Ottoman Empire, wrote the international law textbook, and it was translated and published in Egypt. And he was the representative of Ottoman Empire in the period of British occupation of Egypt by
Thank you.
Yeah, maybe one more. Yeah. Another more?
Thank you so much for this presentation. Of course, Japan is rich in its history, and Egypt, of course. Is there a department in Kyushu about culture, heritage, and there should be like a distribution of this heritage and to make a protocol between Egypt, especially culture, heritage, between the both countries? Especially when we know about the history and the similarity and the comparative studies between both. Thank you.
I think now, どうですかね、遺産管理みたいなことですよね。Yeah, not directly. We cannot find such kind of professor directly, but give me time to, give me and Hamra-san to think about it.
It's the last question. Can be one last question. It's the last question, maybe. Yeah, please. Okay.
Thank you for your presentation. I just have a question. Since I have been in Japan 15 years ago, about the Kuril Islands, between the conflict between Russia and Japan. Till now, this conflict still, everyone knows that these islands are Japanese islands. What is your role or the Japanese role now acting to return back those islands from Russia? Or you have been disappointed and you don't want to go to conflict with Russia?
So, thank you very much for your questions. As an international lawyer, our lawyer is our role is to evaluate or create the argument necessary or the supporting or objective as much as we can. So you mentioned that I think you are mentioning about the 4 island in the north part. So the southern 2 island, I think for these 2 islands, I'm sure it could be Japanese. But the other 2 islands, I think there's a room of the discussion. Yeah. So, but to conduct this kind of argument more objectively, what we can do is that we will create the argument, persuasive or justiciable for all. Yeah. I think it's not a satisfactory answer. I know. I'm sorry. Thank you so much.
Diplomatic answer.
Okay, thank you everyone for your interesting questions and Dr. Oki for your thoughtful answers. Now we will start some closing remarks by Professor Hussein Stour. He is the president of Kyushu University alumni in Egypt. Thank you.
Assalamu alaikum. By the way, Professor Hussein is the president of our alumni, Kyushu University alumni in Egypt. So he now is going to do the closing remarks for all the day.
السلام عليكم جميعا. الحقيقة I would like to say thank you very much for your nice day today. This is a successful day for the first time for KYUDAI now in Egypt. I would like to thank for Professor Shimizu, Vice President of Kyushu University, and all staff members, guests for in Kyushu University, and I hope they enjoyed here in Egypt. Actually, we have many topics about different disciplines, and I would like to make remarks for everyone, but I know you are very tired and maybe. So that is why I will say thanks for all, and I hope for next time to have a chance to be with us again in Egypt, and I hope to have a good stay in Egypt, and welcome for everyone, and thank you very much again. Thank you.
Okay.